evolving landscape of technology presents new opportunities and challenges, and we are poised to navigate them with our signature blended creativity, dedication, and expertise. Today's event is a testament to our own resilience and our shared vision for the future. We have an enriching agenda lined up with insightful presentations, engaging discussions, and opportunities for networking. I encourage you all to actively participate, share your perspective, and make the most of the gathering. Together, we can push the boundaries of what is possible and continue to set new benchmarks in our academics as well as industries. Thank you, sir. Madam is online.
We are so fortunate to have our Madam, Manjushri Madam, the Commissioner, Collegiate and Technical Education. Madam, we all welcome you, Madam. I hope you are, yes, Madam, audibility, yeah. Audibility, please, can you? Madam's voice. Audio, Madam's voice, please. Anyways, yes, ma'am, we are able to hear, ma'am. You have... Yeah. Madam ji, I need not have to introduce about your profile because it is a self-efficacy, but we are fortunate to get this program ignited from your golden words and then elevating the standards of the deliverables of the technical education. Thank you, Madam. It is for you to deliver address the attendees, please. Thank you. Madam ji, 1 minute, 1 second, only 1 second. What is that music going on? Yeah, madam. Sorry.
I hope I am audible now.
Very much, madam. You are very much audible. Correct?
So good morning, everyone. And it is an honor here to be here to the inauguration of this partnership. Gratitude to the director of AIC and Professor Vivekananda organizing this important workshop, which brings together dedicated active experts in the field to explore and integrate the latest technological advancements into our educational framework. Today we are here to dive into the future, and it was not the kind of future where the robots over the world, opening up, but something just as exciting and of course more useful within the electronic instruments. And to guide us into the cutting edge and innovative Indian partner to our building solutions. Now, if we are wondering why do we need to advance intelligence measurements? In the software, we measure everything. The hours of sleep we get. If I should have technology, skills, technique, everything, the art to ensure students are learning. This workshop is here to push space, comfort, this workshop is here to push us out of our old ways, comfort zone, and a zone of wow, we don't know what to do, sort of a zone. In a world where technology is constantly evolving, particularly in the realm of electronic measurements, being current to the global condition, but also essential for who are in the to prepare the next generation. The two methodologies during this workshop happen the teaching is how we approach engineering problems and how we push forward research and industry applications. This is a chance for our faculty also to get on hands-on with the latest tools and techniques that could transform not just what but how we teach. Imagine setting up with the students to take up the challenges of tomorrow before they even graduate. So to everyone I say, be curious, be bold, and let this workshop surprise you. Think of it as a science playground where you can learn, experiment, and even dream a bit about what is next. Remember, innovation does not come from sticking to the script, it comes from daring to explore that. With institutions like Liquid Instruments leading the charge in this domain, we are privileged to gain first-hand exposure to the state-of-the-art equipment and methods that bridge theory with real-world application. I'm confident that this workshop will allow our faculty to harness these innovations in ways that can elevate India's technical education landscape. Let's make this. I make a call to all of you to make this. Call to make this workshop a benchmark for the kind of inventive spirit we want to spread to our classrooms. I urge each of you participating in this workshop to embrace this opportunity with both hands. The knowledge you gain here, coupled with your dedication and expertise, will ripple outward, impacting the students, the institutions that you're working in, and ultimately the broader technological ecosystem of our state. Through this workshop, you become pioneers in embedding these advanced tools and technologies into our curriculum, ensuring that our students remain competitive on a global scale. So let us continue to foster a spirit of collaboration and innovation, recognizing that together we can bring transformative changes to the field of technical education. I look forward to witnessing the outcomes of this workshop and the positive impact it will undoubtedly have on our institutions and students. Thank you again to the Director of Technical Education, Liquid Instruments, Spruha Building Solutions, Indian Institute of Science, AICT New Delhi, and Professor Vivekananda for their commitment to advancing technical education. Let this workshop be a milestone in our journey towards excellence in technical education. Thank you, and I convey my best regards and best wishes to all participating in this workshop. Thank you.
Thank you, madam. Thank you so much, madam. We are so honored to have you and then address, the inauguration of this thing, and then inspire the teachers to deliver their due deliverables, and then getting updated every now and then because the technology is so fast. Thank you so much, madam. Very kind of you. Yes, ma'am. Thanks. In fact, our Australian counterpart also, if you can be there for 5 minutes and then because you're occupied back to back, so if we request only for 5-10 minutes or whatever. Yeah, please.
Yes, sure.
Thank you, madam. Coming back to liquid instruments and MOCO technology, it's time to a little bit brief about it. MOCO technology is not just a tool. It's a transformative force that empowers educators and enhances the learning experience for students. Its versatility is unparalleled, providing a dynamic platform that adapts to the diverse needs of the various academic disciplines. MOCO technology offers a suite of applications that cater to a wide spectrum of educational requirements. The extensibility of MOCO technology is another remarkable feature that sets it apart. It allows for a seamless integration with existing systems, ensuring that educators can leverage their current resources while benefiting from current edge advancements. The adaptability ensures that MOCO technology can grow and evolve alongside the ever-changing educational landscape, providing faculties with the tools they need to stay at the forefront of innovation. I would like to introduce Mr. Amitesh. Mr. Amitesh. Yes, Mr. Amitesh, Director of Channel Sales, EMEA and APJ, Mr. Ben, Director of Product, and Mr. Jobin, Application Engineer. Amitesh, it's over to you.
Hi, hello, Mahesh, can you hear me?
Yeah, I can hear you, Amitesh.
Okay. Is it? Thank you. First of all, thank you very much for organizing this event and making instruments a part of it. We are very excited to be present at this inaugural event and be part of this breakthrough that we are trying to make with advanced technology. We will be joining shortly our Director of Product, Mr. Ben Nizet. He will be delivering a 10-minute presentation on liquid instruments and an introduction to our company, who we are, how did we come to, into forming a company like what we have, and then we will focus on a technical demonstration by our application engineer, Mr. Jobin, who is here as well. So, just to add to what Mr. Mahesh was saying, that MOCO is not just an oscilloscope or waveform generator. It's a transformative tool that will shape the next generation of education and technical breakthrough. Whether it's education, research, or industry, we are developing such a technology that will touch up on all these different segments. So, without further ado, I will hand it over to our Director of Product, Mr. Ben Nizet, to introduce our company and introduce our product. Over to you, Ben.
Thank you very much, Amitesh. Please ask that the Spruha team mute their presentation there. I'm getting an echo. Still echoing there. Well, I will try to present anyway. Let me just share my screen. Here we go. So again, thank you very much for the opportunity to present today and to talk about MOCO, liquid instruments, modern approach to test and measurement, and in particular what we can do using this new technology to facilitate the education of the next generation of engineers, particularly electrical engineers. So first, a little bit about liquid instruments as a company. We have our technical leadership team up on the screen there. There are six of us. I'm the only person there without a PhD, but I have nearly 20 years experience building electronic devices for a whole range of different startup companies. Liquid Instruments itself has been around for about 10 years now. We're a venture capital backed startup company, and we have investors from people like the university that we were spun out of, the Australian National University, right through to international organisations like Lockheed Martin are an investor in us as well, and a believer in our software-defined instrumentation. Most of our technical leadership team, in particular our CEO, COO and chief scientist across the top there, as well as our chief hardware engineer in the bottom right, are all experimental physicists, and they started their careers building laser interferometers for the detection of gravitational waves. And those are the pictures over on the right-hand side here. We were founded by these researchers back in 2014. And our founding team had spent about 10 years of their life before that building software-defined instrumentation for the most sensitive pieces of equipment that mankind has ever built and will build in the near future. And that is the detectors for gravitational waves. We see the LIGO detector at the bottom and the LISA and GRACE detectors at the top. And in particular, the space-based antennas, the LISA and GRACE ones at the top. In order to build this kind of instrumentation, you can't just put boxes in a rack, connect them up with BNC cables and expect it all to work. You need to actually have your instrumentation completely software defined so that when it is up in space, you can still improve the algorithms, you can add new capabilities, and frankly, you can fix problems and fix bugs if they go wrong. And after 10 years building this kind of super high precision software-defined instrumentation for the specific case of gravitational wave detection like this, our founding team turns their attention to using this software-defined instrumentation for wider test and measurement applications across both experimental physics and also into general education, general engineering, and more recently engineering education. So Liquid Instruments now, we've been around for 10 years. We're an innovator and an absolute market leader in this kind of reconfigurable high-performance instrumentation. We have more than 70 employees, mostly based in Australia and in California, but with several across the world in Cambridge, in China, in India. We've shipped more than 4,000 MOCU units, and it's being used, the MOCU is being used by more than 200 institutions. In fact, I think it's close to 300 at the moment. And we have more than 30 distributors globally, although you'll just be working with our friends at Spruha, whom I thank again for the opportunity to jump on today. We are the first group to really look at software-defined instrumentation in a modern way, in a way that allows us to accelerate software-defined instrumentation so that it has the same or better performance than traditional fixed purpose instrumentation. So what do I mean by software-defined instrumentation, and in particular, hardware-accelerated software-defined instrumentation? Well, let's look at traditional approaches to instrumentation first. This is the kind of oscilloscope that was pioneered 50, 60, 70 years ago by Hewlett-Packard and still exists today, as well as fixed purpose signal generators, spectrum analyzers, and the like. In your educational setups, you probably have labs that have desks set up with a fixed purpose oscilloscope, a fixed purpose waveform generator, maybe a fixed purpose DMM, maybe a spectrum analyzer in your later year courses if you're quite lucky. But in all of these cases, you take up a lot of space, there's a lot of complexity, and for any given experiment, for any given lab, for any given course, you might only use one or two boxes. So that leads to a high cost because you have to buy lots of things, but also inefficiencies because you're only using a small number of them at any given time. It also limits what you can teach because you're unable to buy, for example, a spectrum analyzer for every student. Or if you're doing like a control systems course, you may not have PID control setups for every student. You're very unlikely to have FIR and IIR filters that can be used to teach digital signal processing in real time for every student. So that can really hamstring the adaptability of your curriculum, and it can limit the speed at which you can pick up new technologies and teach them to your cohorts. On the other hand, we build our MOCU technology around field programmable gate arrays, FPGAs, and we use those as an accelerator of our core software-defined instrumentation. And by that, what I mean is that you can get software-defined instrumentation. You can get boxes that become oscilloscopes and become waveform generators and become lock-in amplifiers and things. You can get those where the technology, that the algorithms are implemented in pure software on your laptop, or potentially on the high-powered server in your rack. But those are not what we're talking about here. We're talking about the next generation of software-defined instrumentation that loads the algorithms that define your instruments onto the box themselves. It does not do it on my laptop, although my laptop controls it. It loads the algorithms onto the box in an FPGA where they can run extremely fast with low latency in real time. And we do that using FPGA accelerators. And this has been the key transformational technology enabler over the last 10 years that Liquid Instruments has been riding the wave of, is that FPGA technology has been really accelerated by the rise of AI, the rise of cryptocurrencies, network level acceleration for low latency trading. We've been able to leverage that technology explosion and repurpose it for software-defined instrumentation. And as such, we can provide the widest range of software-defined instruments without compromising at all on the performance of those instruments. We believe the future is reconfigurable instrumentation. You probably do not have a dedicated calculator sitting on your desk. You perhaps use your phone or your computer. It's that same paradigm shift that we are bringing to instrumentation, where in the future you will just use this one box, the MOCU, we believe, to be whatever kind of instrumentation you need it to be. We're talking oscilloscopes, spectrum analyzers, waveform generators, and many, many others. The reason for that is that it can adapt to absolutely any challenge. I said that we have MOCUs in more than 200, nearly 300 institutions around the world. One of them was Dr. Jason Clark from Oregon State University in the US. And he was impressed with MOCU because it can become anything you want it to be, not just the standard test instruments that it replaces, but also anything that you can draw in a schematic in Simulink. MOCU can be that as well. He's referring here to one of our other technologies, which is MOCU Cloud Compile, that allows you to write custom instrumentation to solve even the most complex DSP challenges in a very simple and accessible way that even undergraduate students are able to use in a short 3-hour lab. One of the common things that I hear in education is, look, we have to teach using my traditional oscilloscopes because that's what students will use when they go into industry. And look, that may be true today. It's not going to be true for a whole lot longer. We have a huge range of different industrial partners, from first-tier aerospace companies like Lockheed Martin through to Los Alamos National Labs and all the major semiconductor companies, as well as the companies that provide test and production equipment to all of those semiconductor companies. For example, Dr. Samuel Watkins here from Los Alamos said that he's shaving tons of development time off building customized systems because MOCU can just do what he needs to do. They don't spend their time building custom digitization, custom processing logic. MOCU just works. And it's that story that we are hearing from all of our industrial customers that mean that, for example, a semiconductor company who's a customer of ours turned weeks of option into a 20-minute task, literally weeks down to 20 minutes. Those are the success stories that will drive the uptake of software-defined instrumentation in industry, and we believe that your students need to be ready for that, and that MOCU can support you with that. One of the other semiconductor companies that we work with a lot, Intel, they are not the company I was just referring to, but they too have a test setup where they had hundreds of steps a multi-dimensional optimization and characterization problem, and Moku Pro allowed them to simplify that right back down again. So again, success stories all across industry. It's not that you need to prepare your students to use a 50-year-old oscilloscope that just happens to have a better screen on it these days. We believe that you need to prepare your students to think about instrumentation in a different way, to think about it as adaptable as all the software that they use day to day on their laptops. And again, Moku can help with that. So we have some enabling technologies here. I'm not going to spend too much time because my colleague Jobin is going to give you a thorough demonstration of Moku in just a second. But I do want to stop and mention this. So last month, about 3 weeks ago now, we released a neural network instrument that runs in real time on your Moku alongside the rest of your traditional instrumentation. Now, what good might that be? If you think about neural networks as like ChatGPT that answers questions, or even things that categorize images, maybe this is not so important. But what you can use our neural network instrument for is things like anomaly detection in your signal. Rather than setting up an oscilloscope trigger, you can now ask questions like, show me all the signals that are anomalous, that are different. Show me when there's a glitch. Show me when something unexpected happens. Those types of things can now be answered in your oscilloscope, which completely changes the way that you and your students use oscilloscopes, and we believe is going to become the standard way of interacting with oscilloscopes in 5 to 10 years. Moku is trusted by labs across the globe. You can definitely talk to my colleagues about all of the amazing institutes around India who have made Moku a core part of their curriculum. But we also have universities like Stanford, like the US Air Force Academy, Duke University, MIT. They're all using Moku in their education program as a core part of every lab. So let's talk a little bit about the Moku Go. This is our low-end or education-focused version of the Moku product. We have high-end ones that go up to industry-focused, high-speed, very, very capable devices. But the Moku Go is designed to give you everything you need to teach all of your undergraduate and master's labs, and to do it in a package that is affordable, but it's also robust and it's reliable. It's not the kind of thing that your students can break easily, and therefore it's the kind of thing that you can rely on to just work when you go in to run your labs. The Moku Go, again, Jobin will give you a much more detailed introduction to this, but this is 2 analog inputs, 2 analog outputs, some digital I/O, has high input voltage ranges up to 25 volts, has programmable power supplies on the back, so you can use it to run your op-amp circuits, your LED circuits, your external microcontrollers and things like that. And it comes with a suite of instruments that are tailored to the educational experience and to expose your students to the types of things that they would use in industry, but maybe would not normally be able to find in an educational program, like again, spectrum analyzers and so on. The Moku Go is connected over USB or Ethernet, but it's also connected over Wi-Fi, which means that some of the institutes that we're using it with can use it in some of their extracurriculars as well. For example, the Chalmers solar team in Sweden use the Moku Go in their solar car project because they can put the Moku Go inside of their car, monitoring power signals, monitoring battery states while they are driving. They don't need to remain tethered, and as such, they can provide a much deeper insight into the way that their cars are working in order to be globally competitive with their solar car team. Oregon State University, I had a quote from Jason Clark before, they use this to teach their microelectronics design courses, and they use some more advanced instruments. They use PID controllers, they use the lock-in amplifier, things that you would not normally get access to in an undergraduate lab. The Wuhan University of Technology was an early adopter of Moku Go for machine learning tasks, and they used a digital filter box, PID controller, as well as some custom DSP implemented using our cloud compile tool in order to do things like teach adaptive noise cancellation techniques in their master's level DSP courses. I won't go through all of these because there are too many to mention, but again, you can find all of these case studies with our distributor. BattleBots, Oregon State University again, Beijing University of Posts and Telecoms did a vision-based PID control system. UAV identification at the Universidad Politécnica del March, which is a really, really great university teaching wireless comms in a way that they couldn't before. Again, oscillator characterization at that same university, more microscopy at an undergraduate level. We're really enabling things that you otherwise may not be able to teach, as well as improving the way that you can teach your everyday standard day-to-day courses. We do that because Moku is the best software-defined instrumentation platform because it leverages FPGA acceleration in a way that no other platform does without compromising on the user experience and the usability. It offers unmatched flexibility, unmatched cost and efficiency. It has a user-friendly design that your students will know how to use straight away, and that really sets us apart from our traditional tools. Okay, with that said, I would like to thank you again very much for this opportunity. I'm going to hand it over to my colleagues to give you more details and a presentation on how the Moku Go can actually be used. Thank you.
Yeah, thank you, Ben. This is Professor Vivekananda. Anyhow, an instrumentation engineer. But otherwise, I would like to, on behalf of everybody, I would like to place one thing that, from the NASA's platform, you have been going on developing, making the things easy, and the cost affordability also. That is a fantastic thing that has happened. But otherwise, I would like to place a question that, in due course of the advancements of, generative AI kind of, so what is the best that I could know some things that are happening at the back-end operations of, the liquid instruments. But otherwise, from your end, if you can place from the generative AI per se, the advancements, if you can deliver your opinion on that, what is happening with liquid instruments?
Ben, were you able to get the question?
Shall I?
I'm sorry, I may have had a problem with my internet. It was a little bit broken up, but I believe the question was about the uses of generative AI specifically in test and measurement and education, engineering education. Is that correct?
Correct.
That is correct, yes.
Great. Okay. It's a great question. So I am a huge believer in the power of generative AI to help teach complex problems, to help teach complex concepts. One example of how generative AI specifically is being used for engineering education using Moku is using our Moku Cloud Compile technology. Now what this is it allows you to build custom instrumentation and custom DSP that gets deployed into the Moku and it runs in real time alongside the rest of your instruments. So one common use for this might be to write a custom like wireless demodulation scheme and run it alongside the spectrum analyzer to see some properties of your signal. What we're finding some customers doing though is that they can use generative AI to convert algorithms that students have prototyped in MATLAB and in Python. They can convert that into FPGA code that can then be run in real time. So your students are not just limited to simulations. Even without knowing how to program FPGAs, the code generation capabilities of generative AI allow you to take those simulations and then transform them into a way that can be run in real experiments. So your students get to hear what a filter sounds like rather than just looking at a transfer function on the screen, or they get to control a real system rather than just looking at the overshoot characteristics of a trace in MATLAB. So I think that code generation and the ability to transform the domain in which your students are operating is really quite fascinating to me. The one other use case that I'll highlight is that we have a new feature built into our app as of last release about 3 weeks ago that it builds large language model help into the instrumentation itself, into the software-defined instrumentation. And we have a roadmap for that. It doesn't, today it will answer questions about the instrumentation. We have a roadmap for that that allows that LLM to also know the context of your experiment, right? It can see the settings of your oscilloscope as well as the data that is coming out, and it can offer suggestions about, look, I think you need to change your trigger settings, or it looks like your hysteresis is not set correctly, or things like that, that allow you to really handhold a student as they discover what instrumentation is and how it works, without having to have a tutor who is sitting there saying, no, don't do this, do something else instead. So I think those are the two growth areas where I think test and measurement equipment and generative AI overlap at the moment, is code generation to transform the domain in which your students are working without them having to know, FPGA programming, for example, and then also that piece that allows students to explore test and measurement equipment in a supported environment where large language models have insight into your students' configuration and the data and can offer contextual suggestions for how to improve. Hope that answers your question.
Thank you, Ben, for clarifying my doubt, and so it was so exciting to get all the teachers here, academicians. Basically, they are all into teaching for the diploma students, and of course the engineering students also. That segment also is here. And anyhow, what I feel is that with the advancements of the technology, it is a very easy entry to get these instruments being used at a easy stroll. Thank you so much. Very kind of you. Yeah.
Thank you, Ben. Amitesh, if we can continue the overview. Hello? Amitesh, am I audible to you?
Yes, Mahesh, thank you very much.
Yeah, thank you, Ben.
Yes, I can hear you. We can hear you very well. Yeah. Now we will jump into the Moku product itself. We will take you through the interface, the software itself. So it will be a brief technical demo from our side, and I understand that you have the actual Moku goes over there for a hands-on demonstration later. But please allow our colleague, Mr. Jobin, to take it over from here. Thank you.
Thank you, Amish.
Thank you, everybody. I'll drop off now, but please ask any questions of my colleagues and feel free to reach out to me through Spruha in the future. I really am excited to see what you come up with. Thanks again.
Thank you.
Thank you, Ben.
Thank you.
Hello everyone, my name is Jobin. Am I audible and can you see my screen? Sorry, can anybody confirm you can see my screen and I am audible? Assume should be audible.
Yes, you are audible.
Mahesh, can you see our screen?
Yeah, Jobin, you are audible.
Okay?
Yes,
Okay.
we can listen to you. Please go ahead.
Thank you everyone for your time to allow us to showcase the Moku device to you. As Ben mentioned, though the device that you have has no particular interface, the interface is through the app or application software that we developed that you can use to access the MOCU. So the application device can be run on Windows OS, Mac OS, or iPad OS. And once you install and open it, this is the window that you will see once you open it up. As you can see a lot of MOCU devices that are available.
Yeah, let it start. Once it gets started, I will, get through this mode. What I request also is that, please try to jot down the questions, whatever you have to ask. It may be a basic question. It may be a very, very, this thing. So don't worry about asking the questions, please. Unless and until we interact with each other, we will not be entering into the next mode. Okay, so in some classes, just I think a week ago, we were all sitting, Kiran Kumarji, my ex-chairperson of ISRO, our Somnathji, etc. I was asking some 2-3 basic questions. Then I went ahead and then asked, sir, you go to the basics also, you go to the advanced also. So I said, sir, this is what is the human tendency. So let us get into that, and then, because all our responsibilities is to deliver to the students. Students is the task for us. So when such is the scenario, please jot down the questions and then start pushing the questions. See, I asked him what is that they are going to work on generative AI. AI agoytu. AI illari iga. AI otaito. Igirodu generative AI, the present scenario. Okay, so generative AI, when I asked what is that they are doing, he answered. Because...
Sorry, are you communicating with me?
Yes, Jobin. Jobin, you can go ahead. Yeah, I can start.
Hello. Yeah, Amitesh, you can start the call.
Yes, Mahesh, can you hear us?
Yeah. Please go ahead.
Okay, sorry. So was there a question for us?
No, it was not. It was just an interaction session. We lost the connection for that.
Oh, okay,
Yeah.
okay.
Okay, Jobin
All right.
can continue now.
We'll continue here.
Yeah.
Thank you so much.
Can you tell us where did we cut off? Should I start from the beginning?
From the beginning.
Okay, cool. All right. So, as Ben mentioned already, we have our MOCU devices that you can see in front of you. And as you can see, there is no interface to communicate with the MOCU on the device itself, because we developed an application interface that you can run on your Windows computer or your Mac computer to communicate with the MOCU device, and essentially that computer will essentially become your interface to view, to display, and to control the MOCU device itself. So once you install the application software and you open it, this is the window that opens up, and as you can see, I'm able to access the MOCU devices that are connected to the same network as I am. Selecting any of this device will allow you to communicate further with the MOCU, including deploying the instrument that you want, and then essentially do test and measurement services after that. So for this demo, I'm just going to run the demo version of the device that is available in all our application software. So once you open the device, you essentially will have access to all the instruments that we offer. And some of these instruments might be familiar to you, such as the oscilloscope, the spectrum analyzer, the waveform generator, and the arbitrary waveform generator. We also have a bit more advanced instruments, such as the PID controller, the filter boxes, both IIR and FIR, and also some more advanced, so for some more advanced applications, we also provide pacemeter, laser logbox, and time frequency analyzer. For teaching students, you may not use all of these instruments, but these are still accessible on the same device that can be deployed at any time. So to familiarize yourself with what the interface would be, I'm using a very commonly used instrument, the oscilloscope. And so once you click on the oscilloscope, your MoCo device, your MoCo Pro, your MoCo Pro, MoCo Lab, essentially becomes that instrument. So whatever you input into the input port or input channels that you have on your device, that would be displayed on this interface as you can see over here. And similar to traditional oscilloscopes, you have features to horizontally scale, move the waveform, change the time scale, or through, in my case, through the mouse, or if you're using an iPad, through touch. More easy to use features include our smart cursors, which allow you to essentially find time differences or to find the voltage differences between different waveforms. So this also can also be done using our measurement feature, which allows you to measure frequency and other characteristics of the waveform that is ideal for people to characterize what they are seeing. And these can be changed in the menu that is open and can be taken with respect to each other, like you can take the difference between channels, or you can also include a match channel that does this operation for you, including a customized option that allows you to define what function you want with the two channels. Other settings in the oscilloscope, such as the triggers, the channel that you want, and also choose the level that you want. On the display, it's also easily accessible by this marker over here, and that can be changed in real time to see how it moves the waveform. And obviously, this is a very commonly used instrument, especially for introduction to electronics and electrical engineering students. And for them, oscilloscope is the first step to analyze, to measure, and to verify a lot of different circuits, such as analog circuits or digital circuits that they are building. And we do understand, like, one of the main things that we need to have when you're analyzing signals is also generating signals. So instead of having a different device to generate, you can have the waveform generator within the same device that allows you to not only choose sine wave, but different waveforms that are typically available in waveform generator. You can choose a ramp function if you want, choose the amplitude of your choosing, and choose a frequency that you would want the system to run at. And then you can enable it and effectively use that to use it as an input to your system that you are trying to measure. It could be a RLC circuit, it could be an op-amp circuit, or it could be a IC chip that you want to test how the performance is, or what is the functionality of that system when I give the certain waveform to that system. And this is essentially what a lot of universities such as the US Air Force Academy and Australian National University use as a basic principles to introduce electronics and electrical engineering to students. So like I said, you can change this to different types of signals. With a pulse, you can, and with the appropriate trigger setting, you can also show impulse response, you can show step response, and if you are going back to sine wave, you can also get the frequency response of the circuit you are measuring. And when it comes to frequency response, apart from taking different points of frequency and measuring the input and output, we also have another device called the frequency response analyzer or Bode analyzer, which essentially also does the same thing and allows students to verify what they're measuring in the oscilloscope. So this gives you another way of testing what is the transfer function of my device, what is the frequency response of my device. And the interface again is simple to use. You can move it around, zoom in and zoom out to change the frequency span that you want. And you can also change what amplitude should be the input to my test unit, and what should be the span of my frequency ranges that I care about using these settings. And you can change the number of points. Again, everything is available in this one same interface. And similar to oscilloscope, we also provide cursors allowing you to characterize at different frequencies what the performance would be. And so with FRA, you can not only analyze your RLC circuits, you can diagnose any system that you have, any complicated project where you want to give an input signal and you do not know what does the transfer function look like, what is the phase delay in that system. This instrument allows you to measure that with good accuracy and easy to access, easy to use interface. Then after they make the measurement, it's easy to save this by choosing this button over here, and you can save it to your system, or you can send it as an email to your colleague. And this gives you maximum flexibility on how you transfer data, how you share information between groups and different people, in groups and in between different people and different universities. Giving you more flexibility in sharing. Our more advanced feature is our multi-instrument capability. So the multi-instrument capability tries to put two instruments at the same time simultaneously. So if I want an oscilloscope and I want to run a spectrum analyzer, that is completely possible with both of them having the same input. And this is essentially the principle for understanding time domain and frequency domain analysis from a single input source. And if you're using the desktop apps, you have the ability to see both of these windows simultaneously, which means you can effectively see both time domain data and frequency domain data at the same time, making the learning experience more intuitive and more easy to understand about what it means about what frequency shifts mean and other digital signal processing concepts. With respect to Spruha, we did a project with them where we try to implement digital digital communication concepts using our logic analyzer and our waveform generator. So this was essentially trying to develop modulation schemes that are relevant in communication protocols. You can effectively go to your waveform generator, choose the choose the signal or carrier wave that you want to modulate the message or data signal on, and choose the type of modulation that you want, whether it is amplitude or whether it is frequency or if it is phase. And if you're using a pulse signal, then you can also choose to change the width of pulse using PWM modulation as well. And you can choose the input to be given from the pattern generator or logic analyzer, and you can effectively change the modulation depth to your choosing. So in our logic analyzer, you effectively have a oscilloscope setup which allows you to see digital signals in time, and it also as an embedded pattern generator, which allows you to generate different digital signals. That would be very ideal for generating data bits or communication protocols with microcontrollers and, and other digital circuit boards. So you can effectively use the pattern generator to essentially send the message that you want and modulate it using the waveform generator itself. If you feel like some of these instruments are not what you're after, we also have the ability to customize the FPGA itself. And this is a bit more advanced application of the Moku, something that students might be would need, especially if they are into FPGA development or VHDL coding, essentially, and that allows them to essentially develop their own code, their own signal processing concept, and choose some other instrument that they want to pair it with. For example, if they're developing their own controller, they can choose a frequency response analyzer and verify how the system works. And this can be done without any other device but within the one Moku device. And the cloud compile it can be done using our online server. And just to give you an idea, this is essentially our server that allows you to write your own custom code. So here I'm just writing a frequency shift keying protocol, and this I was able to write on my own and then interface or compile the code and then deploy it onto the Moku. And so this gives you maximum flexibility on how you want to simulate signals, how you want to process signals, and how you want to measure signals. And this is essentially what led to Oregon State University. This flexibility is what led to Oregon State University completely made one of the courses 100% remote, because this capability allowed them to teach students the basic concepts through the software-defined approach. And another feature of Moku Go is essentially power supplies. So if you look at the backplate of the Moku device, Moku Go, we also support power supply that can be accessed from any of our instruments simply by clicking on the settings and essentially clicking on the power supply button. And this is useful especially for projects that involves microcontrollers or other microcontrollers such as Arduino, Raspberry Pi, which uses at least a 5-volt power supply, and or if you want to design particular IC chips, you don't need another power supply unit to assist you in setting up the experiment. You have everything in one device. So you can generate waveforms, measure waveforms, generate the power supply for all in one device itself. And so this, again, like I said, it's all happening on one device, and you can change at any point to different instruments, and the device becomes that instrument. So this is a brief and I assume an informative overview of what the Moku is and what the capability is in educating students. Obviously, I would prefer if you have a hands-on experience there, and let us know what your feedback.
Yes.
Thank you, Aish. So that's the demo from our side.
Yes. Thank you, Jovin. Thank you, Amitesh, for joining us and giving your brief demo on this. And thank you once more.
Thank you very much.
Thank you. So, sir, now I introduce Mr. Mahavir, who is our senior technical engineer, to give the demo of the Moku Go. You want to take a break?
So we'll have a 10 minutes break. We'll have a setup of that.
break or something like that, or can we proceed?
Yeah. So just for setup, on 5-10 minutes, we'll set up and we'll, yeah. ಇಲ್ಲ ಇಲ್ಲ ಇಲ್ಲೇ camera.
ಅಲ್ಲೇ
Hello, hello, hello.
ಆಡಿಯೋ ಬೇಕಾಗಿಲ್ಲ, ಆಡಿಯೋ ಬೇಕಾಗುತ್ತೆ, ಆಡಿಯೋ ಬೇಕಾಗುತ್ತೆ. ನಾನು ಮಾತಾಡೋದು ನೀವು ಮಾತಾಡ್ತೀರಾ, ಈಗ ಪಕ್ಕ ಆಡಿಯೋ ಬರಲ್ಲ, ಸ್ವಲ್ಪ ಈ ಫ್ಯಾನ್ ಸೌಂಡ್ ಗಾಡಿ ಎಲ್ಲ ಬರುತ್ತೆ. ಈಗ ಅಲ್ಲಿಂದಲೇ ಝೂಮ್ ಮಾಡೋದು, ಕನೆಕ್ಷನ್ಸ್ ತೋರ್ಸೋಕೆ ಕಷ್ಟ ಇದೆ.
ಅದೇ ಬೇಕು, ಕನೆಕ್ಷನ್ಸ್ ತೋರಿಸ್ಬೇಕು, ಇಲ್ಲ ಅಂದರೆ ಲೈವ್ ಮಾಡಿ
ಟೇಬಲ್ ಒಳಿಸಿ,
ಟೇಬಲ್ ತಿರುಗಿಸಿ
ಕನೆಕ್ಟ್ ಮಾಡೋದಿಲ್ಲ ಈ ಕಡೆನಾ? ಇಲ್ಲೇ ಕನೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಇಲ್ಲ, ಕನೆಕ್ಷನ್ ಇವ್ರು ಮಾಡ್ತಾರೆ. ವೈರ್ ಅಷ್ಟೇ.
ಲೈವ್ ಇವ್ರು ನೋಡ್ಕೊಂತಾರೆ ಕ್ಯಾಮ್ರಾ.
All the attendees and participants of online session, hybrid session, please be online and yes, correct.
ಸ್ವಿಚ್ ಕೊಂಡು ಬಿಚ್ಚೋದು ಬೇಡ, ಹಂಗೆ ತಿರುಗಿಸೋದು ಇದೆ ಅಷ್ಟೇ.
Whomsoever are in the hybrid mode, online mode, please be online and the session will start another 5 minutes or so. There is a small break that has happened because the practical setup is going on, and therefore we request you to hold on for some time and then join after maybe 5 minutes. Thank you so much.
ಹಿಡ್ಕೊರೋದನ್ನ ಯಾರು ಅಷ್ಟೇ ಬರುತ್ತೆ ಬರುತ್ತೆ. ಅದೇ ಮಾಡ್ಬೇಕು ಈಗ ಅಷ್ಟೇ. ಈಗ ತೊಗೊಳ್ರಿ, ಸಾಕು ತೊಗೊಳ್ಳಿ ಸರ್. ನೀವು ಈ ಕಡೆ ಕೂತ್ಕೊಳ್ಳಿ ಅಷ್ಟು, ನೀವು ಇಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಮಾಡಿ ಅಷ್ಟು. ಇಲ್ಲಿ ಚೇರಕ್ಕೆ ಕೈ ಕಾಣಿದ್ರೆ ಸಾಕು ನಿಮಗೆ. ತೊಗೊಳ್ಳಿ, ನೀನು ತಗೊಳ್ಳೋದೇನು ಬೇಡ, ಕೂತ್ಕೊಳ್ಳಿ.
ಫೋಟೋ ತೆಗಿತ ಸಿಂಪಲ್ ಕನೆಕ್ಷನ್ ಸರ್.
ಹೌದಾ, ಗೊತ್ತಾಗಬೇಕಲ್ವಾ ಸರ್ ಅವ್ರಿಗೆ.
ಈ ರೇಂಜಿಗೆ ಓಡಿಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದರೆ ಇದು ಡಿಸ್ಪ್ಲೇನ್ ಆಗಲ್ಲ. ಅಲ್ಲ ಅಲ್ಲ ಸರ್, ಇದು ಈ ಪರಿ ಲೈಟ್ ಇತ್ತು ಅಂದರೆ ಅದನ್ನು ನಾನು ಹೇಳೋದು ಕಾಣಲ್ಲ ಸರ್ ಅವ್ರಿಗೆ ಯಾರಿಗೂ.
ಅಲ್ಲಿ ನೋಡಿ ಸರ್, ಅಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಮಾತಾಡಿ.
ಅಲ್ಲಿ ಒಬ್ಬರು ಇರ್ತಾರೆ ಸರ್, ಇವ್ರು ಈ ಕಡೆ ಕೂತವ್ರಿಗೆ ಅದೇನೋ ಸ್ವಲ್ಪ ಕೆಳಗಿಳಿಸೋಕ್ಕಾಗಲ್ವ ಕ್ಯಾಮ್ರದ ಹೈಟ್ನ? ಹೈಟ್ ಕೆಳಗಿಳಿಸ್ಬೋದಲ್ಲ ಸರ್ ಕ್ಯಾಮ್ರದ್ದು? ಅಲ್ಲ ಅಲ್ಲ, ಹೈಟ್ ಸ್ವಲ್ಪ ಕೆಳಗಿಳಿಸ್ಬೋದಲ್ಲ? ನೀವು ಬರೀ ಇಲ್ಲಷ್ಟೇ ಫೋಕಸ್ ಮಾಡಿ ಸರ್, ಸಾಕು. ಸಾಕಾ? ಹಾಂ ಸಾಕು, ಅದು ಕಂಡ್ರೆ ಸಾಕು. ಇದಿಷ್ಟು ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್, ನೋಡೋಣ ಹೆಂಗೆ ಕಾಣುತ್ತೆ. ಓ ಓಕೆ ಸಾಕು ಸರ್, ಮೋರ್ ದೆನ್ ಇನಫ್ ಸರ್. ಇದ್ರ ಮೇಲೆ ಫೋಕಸ್ ಮಾಡಿ ಸರ್, ಕನೆಕ್ಷನ್ಸ್ ಇಲ್ಲಿ ಮಾಡ್ತಾರೆ ಸರ್. ಕನೆಕ್ಷನ್ ಇದು ಇಷ್ಟು ಪೋರ್ಷನ್ ಮಾತ್ರ ಬೇಕು, ಸಾಕು. ಇದು ಏನೂ ಬೇಕಾಗಿಲ್ಲ. ದಿಸ್ ಇಸ್ ನಾಟ್ ನೆಸೆಸರಿ, ದಿಸ್ ಪೋರ್ಷನ್ ಅಷ್ಟೇ.
ಓಕೆ ಸರ್. ಇಲ್ಲಿ ಕೂತ್ರೆ ಕಾಣಲ್ಲ.
ಅಲ್ಲ ಸರ್, ನೀವು ಇದು ಕನೆಕ್ಷನ್ಸ್ ತೋರಿಸ್ತೀರ, ಅದು ಎಲ್ಲಿಂದ ತೋರಿಸ್ತೀರ ಸರ್ ನೀವು ಲೈವ್ ಇವ್ರಿಗೆ? ಅದು ಕಾಣಲೇಬೇಕಲ್ಲ ಸರ್ ಔಟ್ಪುಟ್. ಎರಡು ಹೆಂಗೆ ಕಾಣುತ್ತೆ? ಈಗ ಇದು ಇಲ್ಲಿ ಫೋಕಸ್ ಮಾಡಿದ್ರೆ ಅದು ಹೆಂಗೆ ಕಾಣುತ್ತೆ? ಒಂದು ಇದನ್ನಾದ್ರೂ ತೋರಿಸ್ಬೋದು, ಒಂದು ಅದನ್ನು.
ಇನ್ನೊಂದರಲ್ಲಿ ಲಾಗಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಇನ್ನೊಂದು ಮಾಮೂಲಿ ಮೀಟ್ ಇದೆ, ಗೂಗಲ್ ಮೀಟಲ್ಲಿ. ಇದು ಪ್ರೆಸೆಂಟೇಷನ್ ಅಲ್ವಾ ಸರ್? ಈ ಪ್ರೆಸೆಂಟೇಷನ್ನ ಒಂದು ಕಡೆ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ ಲಾಗಿನ್ ಲೈವ್ ಅಂತ ಬರುತ್ತಲ್ಲ ಸರ್, ಲೈವ್ ತೊಗೊಂಡಿದ್ದಾರಲ್ಲ, ಒಂದು ಲಾಗಿನ್ ಮಾಡಿದ್ರೆ ಅದು ಬರುತ್ತೆ. ಇನ್ನೊಂದು ಗೂಗಲ್ ಮೀಟಲ್ಲಿ ಲಾಗಿನ್ ಮಾಡಿ ಈ ಬ್ಯಾನರ್ನ ಎತ್ತೀವಿ, ಡಿಸ್ಪ್ಲೇ ಅರ್ಥ ಆಯ್ತಾ ಸರ್? ಅವಾಗ ಅದನ್ನು ನೋಡ್ತಾರೆ, ಅದನ್ನು ನೋಡ್ತಾರೆ, ಯಾವ್ದು ಬೇಕಾದ್ರೆ ಚಾಯ್ಸ್.
ಸರ್ ನೀವು ಇದು ಕನೆಕ್ಷನ್ ಮಾಡಿದ್ಮೇಲೆ ಮುಂದೆ ನಾನು ಏನೇ ಮಾತಾಡಿದ್ರು ನೀವು ಅದನ್ನು ತೋರಿಸಿಲ್ಲ ಅಂದ್ರೆ ವೇಸ್ಟೇ ಸರ್. ನಾನು ನಿಮ್ಗೆ ಅದಕ್ಕೆ ಅದು ಬೇಡ ಸರ್ ಕನೆಕ್ಷನ್ಗೆ ಅಂತ ಹೇಳಿದ್ದೆ. ದಟ್ ಇಸ್ ನಾಟ್ ನೆಸೆಸರಿ. ಅದಾಗಲ್ಲ ಸರ್.
ಅಲ್ಲ, ಇದರಲ್ಲಿ ಒಂದು ಬ್ಯಾನರ್ ಬರುತ್ತಲ್ಲ,
ಬರೀ ನೀವು ಕನೆಕ್ಷನ್ ತೋರಿಸಿದ್ರೆ ಔಟ್ಪುಟ್ ಎಲ್ಲಿ ತೋರಿಸ್ತೀರಾ ಸರ್? ಅಲ್ಲಿ ಮಾಡೋ ಸೆಟ್ಟಿಂಗ್ಸ್ ಎಲ್ಲಿ ತೋರಿಸ್ತೀರಾ ಸರ್? ನೀವು ಅದನ್ನು ಅಷ್ಟೇ ಇಟ್ಟು ತೋರಿಸಿದ್ರೆ ಸಾಕಾಗಿತ್ತು ಸರ್. ಇದು ನೆಸೆಸಿಟಿ ಇರಲಿಲ್ಲ ಸರ್, ಅಷ್ಟೇ ಸರ್. ಹಾಂ ಸರ್, ಅದು ಹಂಗಿಲ್ಲ ಸರ್. ಅದು ಕನೆಕ್ಟೆಡ್ ಟು ಇನ್ಸ್ಟ್ರೂಮೆಂಟು. ಅದು ಪೂರ್ತಿ ಇನ್ಸ್ಟ್ರೂಮೆಂಟನ್ನು, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನ ಎಲ್ಲ ಅದೇ ಕಂಟ್ರೋಲ್ ಮಾಡೋದು ಸರ್. ಅದಾಗಲ್ಲ ಬಿಡಿ ಸರ್. ಈಗ ನೀವು ಬರೀ ಇಲ್ಲೊಮ್ಮೆ ಅಲ್ಲೊಮ್ಮೆ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ ಸರ್. ಅದು ಮಾಡ್ಬೋದಾಗಿತ್ತು ಹಂಗಿತ್ತು. ಆಗಲ್ಲ ಸರ್. 1 hour ಮೇಲೆ ಹೋಗ್ಬೋದು. ಹಾಂ ಅಷ್ಟೇ ಸರ್, ಅದು ಈಸಿ ಆಗುತ್ತೆ ಸರ್. ಮೇಲ್ಗಡೆದೇ ಈಸಿ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಕುಂತವ್ರಿಗೆ ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗುತ್ತೆ ಸರ್. ಹಲೋ, ಇಲ್ಲ ಇಲ್ಲ, ಅದನ್ನೇ ತೋರಿಸಿ ಅಂತ ಇದ್ದಾರೆ ಅವರು. ಅದಕ್ಕೆ ಫೋಕಸ್ ಮಾಡಿಬಿಡಿ.
Setup is ready. Participants, setup is ready. You all can please assemble back for the session to continue, please. Setup is ready, please. Everybody can join back.
PPT ಓಪನ್ ಮಾಡಿ. PPT ಓಪನ್ ಮಾಡಿ. ಚೇರ್ ಹಾಕ್ಕೊಳ್ಳಿ ಫಸ್ಟ್. ಎಲ್ಲಿದೆ ನಿಮ್ಮ ಚೇರ್? ಅಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಹಾಕ್ಕೊಳ್ಳಿ. ನಿಮ್ಮ ಚಾರ್ಜರ್ ಎಲ್ಲಿದೆ? ಎಲ್ಲಿಟ್ಟಿದ್ದೀರಾ? ಎತ್ಕೊಂಡು ಹಾಕ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಕೊಡಿ, ಸಿಗಿಸ್ತಾನೆ ಅದು. ಹಲೋ ಹಲೋ. ಅಲ್ಲ ಇದು ಮೂಗಕ್ಕೆ ಬಂದಿತ್ತಲ್ಲ ಚಾನಲ್ಸ್. ಇದರಲ್ಲಿ ಸ್ಕ್ರೀನ್ ಇದನ್ನು ಮಾಡ್ಕೊಳ್ಳಿ, ಡ್ಯೂಲ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಮೂಕುದು ಇದು ಸ್ವಲ್ಪ ಹಿಂಗೆ ತಗೊಳ್ಳಿ. ಭಾಳ ಚಿಕ್ಕದು ಮಾಡ್ಕೊಳಕ್ಕೆ ಹೋಗೋದು. ಹಾಂ ಅಷ್ಟು ಇರಲಿ. ಓಕೆ, ಸ್ವಲ್ಪ ದೊಡ್ಡದು ಮಾಡ್ಕೊಳ್ಳಿ. ಅಷ್ಟೇನಾ? ಇದನ್ನೊಂದು ಸ್ವಲ್ಪ ದೊಡ್ಡದು ಮಾಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಅದಕ್ಕೆ ಜಾಯಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಹಾಂ ಬಿಡಿ. ಇದೆ
ಅಲ್ಲೂ ಒಂದಿದೆ. ಯಾವ್ದು ಬೇಕಾದ್ರೆ
ಪಾಯಿಂಟರ್ಗೂ ಅಂದರೆ ಎಷ್ಟು ಕಡೆ ಐತೆ ಯು ಎಸ್ ಬಿ ಬೋರ್ಡ್ ಇಲ್ಲವೇ ಇಲ್ಲ.
ನಿಮಗಲ್ಲ, ನನ್ನ
ಪಾಯಿಂಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನಾನು ಇದಕ್ಕೂ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ.
LED ಮಾತ್ರ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್. ಇದನ್ನು ಲೇಸರ್ ಆನ್ ಮಾಡಿದ್ರು ಸರ್. ಇದೆ ಸರ್. ಅದು ಎಲ್ಲಿ ಹೋದ್ರು ಸರ್? ಸರ್ ಎಲ್ಲಿ ಹೋದ್ರು ಸರ್?
ಏನು ಬೇಕು?
ಇದು ಸರ್
ಸ್ಲೈಡರ್.
LED ಸ್ಲೈಡರ್ ಬೇಡ ಸರ್.
ಅದೇ ಗೊತ್ತಾಯ್ತು.
ಪಾಯಿಂಟರ್ ಅಷ್ಟೇ ಸರ್.
ಇವಾಗ ಶುರು ಮಾಡಿ.
Good morning all. Myself Mahavir here. I am from Spruha Building Solutions, and my colleague Manoj will also be taking care of a system part here. So as you all saw what Mr. Ben has said and Mr. Jobin has said about our instrument, I'll just start with a brief recall of the things what our instrument is basically. So most of the instruments what we use all are ASIC based in our lab, be it DSO, be it function generator, be it. So what our scientists and our CEO, our company people thought that why not use the technology which is already present, which is FPGA, for a hardware part of the particular test and measuring instruments. So they have developed this particular instrument called MOCU. So this is MOCU. We have 3 variants in it. This is Moku Go. This is specifically designed for educational institutions. Yeah. So, am I visible to all? Okay. So same thing is there also. You can see it in the display. So our Mokugo, it weighs below 1 kg and it can perform the functionality of nearly around 11 instruments. So it's a software defined test and measuring instrument. So you'll be needing a software. This is the second part. So this portion is our Mokugo. Manoj, if you can just come outside. Outside. To the lab. App, beginning, main menu of the app. Again, come back. So once we on our app, Mokugo, you can see which are the instruments connected. We have connected 2 instruments to our laptop here. This is the number of each and every instrument. They have a unique different numbers. So we will be logging into this particular Mokugo now. No, this one, 2335. So you can get a menu here. So menu means if I am conducting a particular experiment. So we will start with a small experiment like clipper, PPT. PPT ಹೋಗಿ direct slide. ಇದಕ್ಕೆ clipper. Screen share ಮಾಡಿ. So to do a clipper experiment, we will be requiring one DSO and one function generator. So what we are going to do is that we will be using our oscilloscope. If we press oscilloscope, our Mokugo will configure itself as an oscilloscope now. So similarly as an oscilloscope, it has 2 channels, channel A, channel B, as you can see here, channel A, channel B. So below that there is something called as source.
Red axis is channel A, blue axis is channel B.
Yeah, red is channel A. You can define the color also as per your requirement. That's not an issue there. When you say source means which the particular signal I want to display on the screen. Whether I want to display a signal connected to my input 1 channel, or whether it is connected to input 2 port, or whether it is connected to output 1 port or output 2 port. So which signal I want to project here, that signal I have to select here. So we will be connecting circuit now. Before that, we have inbuilt function generator also inside our Mokugo, as you can see. So this part will define different kind of signals what we can generate, be it sine, square, ramp, pulse, noise or DC. And this is where we can define the frequencies from millihertz to 20 megahertz maximum we can generate through our Mokugo. And here we can define the amplitude from millivolt peak to maximum 10 volts peak to peak. So now we are going to set it for 1 kilohertz, frequency to 1 kilohertz. And amplitude to 6 volt peak to peak. We can define even phase also, we can define even offset also for the signal. And to turn on the signal, we have to press this particular point. So you can see I have connected the circuit to my Moku here. Here my Moku is connected to a discrete circuit, which comprises of a diode and a resistor, similarly like this. You can see this is our input and this is our output which is coming through the circuit. So this is a clipped output. So to do the measurements we can do manually also by using cursors. We can just, or we have something called as measurements here, where if we just go on adding, it can display nearly around 21 parameters which we can measure. It will directly measure and it will display it on the screen. We can overlap also by just syncing the channel scales. We can even store the signals. If you go here, cloud, we can store the traces either in CSV format or a MAT format. We can take the screenshots. We can even store the settings, measurements with a high resolution also. You can store it in your particular desktop, or you can just store it to, you can share it in a cloud also. That also you can do. So we have one more channel in it. If you come here, which is called as math channel. If you want to perform any mathematical operations like addition, subtraction, multiplication, XY mode, if transfer characteristics also, you can just check it here. Double click, double click. Double click, double click. This is the transfer characteristics of the clipper circuit. Or you can take the FFT also for each signal. FFT is nothing but it's a frequency output display in a frequency domain. So this is all about our DSO. We have inbuilt power supplies also. We have 4 variable power supplies with the different ranges, -5 to +5, 0 to 16 volts with current rating of 150 milliamp, and 0.6 to 5 volts and 0.6 to 5 volts with a current rating of 1 ampere. So these are all variable power supplies. So these all instruments can be used simultaneously. So till now, if there is any doubt, if any clarification is required, I can just take some doubts, or we can proceed. Yes, ma'am. We have connected it to directly to discrete components also.
Basically, the advantage of this Mokugo kind of, not necessary that this has to be conducted in the laboratory itself. My teachers at VTU and then my IIT, in fact, my IIT Mumbai has got this, an advanced one, where we take this to the classrooms, connect to my laptop. Students will bring the circuits. They will design their circuits. They will connect it. And then within no time, they try to configure and then see the outputs. With whatever the input waveforms we give, that is what. Yeah, please.
There are 3 ways, ma'am, we can interface Moku to our systems, either with C2C or C2 USB, or through LAN cable also, RJ45, or you can connect it remotely also. We have given like a hotspot, we have given a Wi-Fi, so you can connect it remotely also. Without any wired connection, interfacing can be done remotely also.
It will not take much time. If you can batch by batch, 3 or 4, please.
It has a passive probe with a 10x and 1x. You can change. Then
maximum voltage that
batch by batch you can come. 4 each. 4 each can stand and then
ours
come
in
here
a
see the scenario here. You will have a practical experience, please.
we can give a power supply through our power supply itself, sir, which is there, ma'am, which is there in our Mokugo itself.
No, it is inside, but externally we should give
You,
process,
the power supply.
you are not giving, taking from there itself,
Yes,
right?
yes, ma'am.
And where you have taken?
Here. Here, ma'am. We do A.
So this is the output one.
We are not giving
So
the voltage.
what are the signal they are generated 1 kilohertz, and this it is output means the signal is coming out of the Moku and it will be given as an input to your
We
circuit.
have a probes here, ma'am.
Yeah. So the output it will be taken as an input to the Moku. So your input output means, so output which is signal is coming out of the Moku, what we have generated signal, and this Yeah, this is a waveform generator. This we are giving as an input to the circuit. Okay, from the circuit, what you want to take the output and
these are
display,
power supply
that it will be
ports, what we have.
oscilloscope.
This is a common
So these two are
ground.
oscilloscope
Both these
and
are
these
power
two are function generator.
ಎಲ್ಲ
Yeah.
just a ನಿಮಿಷ ತೋರ್ಸಕ್ಕೆ ಅಂತ and this one is positive. So the ground ಆಗುತ್ತೆ ಮ್ಯಾಮ್ ಇದು ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಗಿವ್ ಇಟ್ ಅದ್ರ ಒಳಗಡೆ ಎಲ್ಲ ಆನ್ ಮಾಡ್ಬೋದು ನಾನು 4 ತೋರಿಸಿದ್ನಲ್ಲ ಮ್ಯಾಮ್ -5 to +5 0 to 16 0.6 to ತಗೋಬೋದು ಮ್ಯಾಮ್ ನೀವು ಪವರ್ ಸಪ್ಲೈ ಸಿಗ್ನಲ್ಲು ಪ್ಲಸ್ ಡಿ ಎಸ್ ಮೂರು ಒಟ್ಟಿಗೆ ನೀವು ಯೂಸ್ ಮಾಡ್ಬೋದು ಕನೆಕ್ಷನ್ ಕೊಡೋದು ಪವರ್ ಸಪ್ಲೈ ಇಲ್ಲಿಂದನೇ ಕೊಡೋದು ಮ್ಯಾಮ್ ಎಸ್
Exactly.
ಮ್ಯಾಮ್
Exactly. Maximum voltage limit.
Maximum voltage only it has an input impedance of 1 mega ohms. So whatever you will be sending it in, it will not exceed more than 10 volts, peak to peak, peak to peak.
impedance now
That is 20 volts. Not more than 10 volts peak to peak, ma'am. Where?
25 volts analog input. That's what specification what you will put down. It is specifically
Where?
just 25 volts or 10 volts or how much it is.
You can measure up till 30 volts also, ma'am. You can measure, but you can't generate. Only you can generate up till 10 volts peak to peak in the signal generator, ma'am. If you are
But you cannot
generate. Maximum is 16 volt, ma'am. You can generate. You can use normally you can use normal BNC cables. These are BNC ports only, ma'am.
These are BNC.
Transistor as a circuit of the basic transistor, we should give 2005 volt supply, AC supply. And so I should take wiring from this laptop and give to the external harmony.
Yes, ma'am.
And the output should be given to this motor.
Yes, yes.
1.5.
You can check.
System consensus, this whole device 1.5.
ಬಯಾಸಿಂಗೋಸ್ಕರ ಪವರ್ ಸಪ್ಲೈನೂ ಬೇಕಾಗುತ್ತೆ ಮತ್ತೆ ನಾವು
ನೀವು 4 ಪವರ್ ಸಪ್ಲೈ ಇದೆ ಮ್ಯಾಮ್
We need a computer.
4 at a time use ಮಾಡ್ಕೋಬಹುದು ಮ್ಯಾಮ್ ಯು ಹ್ಯಾವ್ ಟು ಟೈಪ್ ಎವ್ರಿ ಟೈಮ್ ಹೌ ಮಚ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ ಯು ಹ್ಯಾವ್ ಟು ಟೈಪ್
So ಅದು ಇಲ್ಲೇ ಒಳಗಡೆ
ಒಳಗಡೆ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ನೀವು ಮಾಡ್ಬೋದು ಅಲ್ಲಿ ನೀವು ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇ ಇದೆ ಡಿಸ್ಪ್ಲೇ ಪವರ್ ಸಪ್ಲೈ
ಈಗ ನಾನು ಎಕ್ಸ್ಟರ್ನಲಿ ಸರ್ಕ್ಯೂಟ್ಗೆ
ಇಲ್ಲಿದೆ ನೋಡಿ ಮ್ಯಾಮ್ ಪವರ್ ಸಪ್ಲೈ ಬ್ಲೂ ಪಾರ್ಟ್ ಇದೆಯಲ್ಲ ಬ್ಲೂ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ವೇರಿ ಮಾಡಿ ತೋರಿಸಿ ಇಲ್ಲ ಅಲ್ಲ ಆನ್ ಮಾಡೋಣ ವೇರಿ ಮಾಡಿ ಹೆಚ್ಚು ಟೈಪ್ ಅಲ್ಲಿ
If I set 3 volts, can I measure from 3 volts from this?
ಎಸ್ ಮ್ಯಾಮ್ ಎಸ್ ಮ್ಯಾಮ್ ಎಸ್ ಮ್ಯಾಮ್ you just have to take it connect it to multimeter ma'am. First and negative you just connect it, you will just come to see.
Adjustment we should do it in software.
Because it's a software defined, ma'am. Whatever changes whatever commands you have to give, you have to give it through our GUI itself. So Mokugo is just like a body and our software is just like a brain. Without a brain body can't function the same way it is there.
ಸೊ ಇದ್ರ ಜೊತೆ ನಮಗೆ ಅಟ್ಯಾಚ್ಡ್ ಒಂದು ಲ್ಯಾಪ್ಟಾಪ್
Laptop ante ashtalla ma'am, you can use desktop also. Even you can, if you are having iPads, you can connect it with the iPad also. Yes ma'am. It's a open software ma'am. Anybody can download. You just visit our Liquid Instruments website. There you will get a link. You can directly download it. But only specification required is your Windows should be 10 plus, not below 10, because it's compatible only with Windows 10 plus.
1.5 lakh.
So one device means
Inclusive of tax.
plus power supply.
Moku full device. Power supply is the inbuilt one. Moku with the software.
ಎಲ್ಲಾನು ಬರುತ್ತೆ ಇದೊಂದು equipment ಅಲ್ಲಿ ಎಲ್ಲ ಬಂದ್ಬಿಡುತ್ತೆ ಪವರ್ ಸಪ್ಲೈ ಸಿಗ್ನಲ್ ಜನರೇಟರ್
No, I have connected it to this circuit. We are using different experiments because every time if we go on connecting, it will take a lot of time. So demo.
ಆಗಿ ನಮಗೆ ಸಿಗ್ನಲ್
ಮಾಡ್ಬೋದು ಮ್ಯಾಮ್ ಮಾಡ್ಬೋದು ಇಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿಲ್ಲ ಮ್ಯಾಮ್ ಇಲ್ಲ ಇದು ಒಂದೇ ಮಾಡಿದ್ದೀನಿ ಮ್ಯಾಮ್ ಇದೊಂದು ಎಕ್ಸಾಂಪಲಿಗೆ ಇಲ್ಲಿ ಒಂದೇ ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ ಮ್ಯಾಮ್ ಈ ಲ್ಯಾಪ್ಟಾಪಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿದೆ ನೋಡಿ ಮ್ಯಾಮ್ ಎರಡು ಪವರ್ ಸಪ್ಲೈ ತೊಗೊಂಡಿದ್ದೀನಿ ಮ್ಯಾಮ್ ನಂದು ಅನಲಾಗ್ ಇನ್ಪುಟ್ ಚಾನಲ್ಸ್ ತೊಗೊಂಡಿದ್ದೀನಿ ದ್ಯಾಟ್ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಟು ಮೈ ಸರ್ಕಿಟ್ಸ್ ಹಿಯರ್ ಟು ಟೇಕ್ ಎ ಇನ್ಪುಟ್ ಆ್ಯಂಡ್ ಟು ಗಿವ್ ಔಟ್ಪುಟ್ ದಿಸ್ ಇಸ್ ಅ PID controller ma'am. So in a PID controller, how to tune a PID controller, that's what we are displaying with a small what you can say, process of controlling the level of that particular ball. The ball should be controlled at a particular level by applying different Kp, Ki and Kd values. After that, for that we have designed a small circuit here where it will be generating a PWM signal. The width of that PWM signal will be controlled by our PID controller. And the feedback is taken through this sensor and it is fed to our PID controller. You can just see here, this is our PID controller, block model, you can just check it. We can change the different values in it. So here I have used PID controller to get and to analyze the signal, and I have used the power supply also. So the same question you were asking, ma'am, we can use them simultaneously. No, ma'am. This is a standalone instrument. This is a standalone instrument. That is a standalone instrument. For various experiments, we are connecting these.
Setting up here for a different thing, but in the lab you can carry only one.
One.
Not necessarily only this one laptop and circuit.
For this particular circuit, I have used this particular setup. Home also, ma'am. That will always be there, ma'am. But one thing, ma'am, it doesn't require calibration and it doesn't have any knobs. ಈಗ ಹೆಂಗಾಗುತ್ತಂದ್ರೆ ಮ್ಯಾಮ್ ಕೆಲವೊಮ್ಮೆ ಔಟ್ಪುಟ್ ಬರಲ್ಲ, ಸೊ ಅದ್ರದ್ದೆಲ್ಲ ಫ್ರಸ್ಟ್ರೇಷನ್ ಹುಡುಗರು ನಾಬ್ಸ್ ಮೇಲೆ ಹಾಕ್ತಾರೆ ಮ್ಯಾಮ್. ದೇ ಕಾಂಟ್ ಡೂ ಹಿಯರ್. ಆಮೇಲೆ ಮಿಸ್ಚೀಫ್ ಏನೂ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಮ್ಯಾಮ್ ಅವ್ರಿಗೆ. ಪ್ರೋಬ್ ಇಲ್ಲದೆ ವೈಫೈ ಕನೆಕ್ಷನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಕನೆಕ್ಷನಿಗೆ ಪ್ರೋಬ್ ಬೇಕೇ ಬೇಕು ಮ್ಯಾಮ್. ಟು ಓನ್ಲಿ ಇಂಟರ್ಫೇಸ್ ಯು ಕ್ಯಾನ್ ಡೂ ಥ್ರೂ ವೈಫೈ. That next we will show.
Yes, sir. And a small update about this instrument is, so this is an FPGA-based software-defined test and measuring instrument. And the software is an open software, so there is no licensing for the software and all. And it is a one-time investment of the instrument where there is no calibration required. Since everything is in a digital format, no calibration is required and no maintenance also is required. Because there is no knobs and other thing where it will get damaged. So no calibration, no maintenance is required. So
no annual maintenance required. If you have power generator, oscilloscope, and signal generator, there is an AMC needed, annual maintenance contract. If at all the institute agrees upon the AMC cost is not there. That is also one more thing that I wanted to. 1.5. There are 3 modules. Lab and then advanced. But for the basic entry level of diploma kind of engineering, this is something.
this is a software interface is doing. So software, what are the inputs we are giving through the software? Software and hardware, it will be interfaced. So and what are you are giving the voltages, circuits through this one, it will be connected to the circuits only. Okay. No, from the circuit we are connecting to the Mokogu. Yes, sir.
When we say interfacing will happen only between our Moku and our software which will run that Moku.
Yeah.
This is connections, sir. Input connections and output connections, sir.
Connection.
Yes.
Yeah.
Interface. That we can do either with C2 USB port, or you even have Ethernet. If you have a LAN cable, you can connect it through the LAN also. Or if you want to connect it remotely, you don't want any wired connection between my PC and Mokugo, you will be having a Wi-Fi number of this particular thing. A password will be there. You can directly connect with Wi-Fi also. So interfacing can be done in 3 ways. Either through RJ45 or through C cable or through Wi-Fi. So now we will be showing one more instrument as sir was explaining, Mr. Ben and Mr. Jobin was explaining about that, which is called as frequency response analyzer.
Sir, ಸ್ವಲ್ಪ
ಏನು ಬರ್ತಾ ಇಲ್ವಲ್ಲ ಇದು?
This is software is free. Focus is free. You can download. So in that you can use simulations.
FRA ಬನ್ನಿ ಸರ್. FRA. So this is called as frequency response analyzer. So we will be connecting a network to it. You can call it as a network analyzer also. So if you can see the red line, it is showing a Bode plot, magnitude plot and a phase plot of a particular network what we have connected. If we can see the plot, we can make out what network we have connected or what circuit we have connected. As we can see, it is not leaving the low frequencies out, the amplitude is going dropping. After a certain point, it is passing the band of higher frequency. So we have connected it to high pass filter, RC coupled high pass filter. So to do this experiment in our lab, we will be taking discrete values at a different frequency, and at the cutoff or minus 3 dB, we will calculate and we will plot it on a, on a graph. So same thing you can get it directly by connecting. The major advantage of FRA is that, okay, we have connected a smaller network here. What if we have some complex network? What is the basic principle how our frequency response analyzer works is that it will be sending a sweep of a sine wave from a certain frequency to a certain frequency, and it will collect back the whatever the response of the network will happen, and it will plot it. So for a complex circuit, you just have to connect input port and you have to connect at the output port. Then you will come to know what kind of a circuit we have connected in between. So it will be very good for prototype testing when you are doing R&D or you are testing a particular instruments. So you can check the response of that particular circuit. So it will be a very important tool for that. Instead of doing for a different, every time we are changing the frequency and checking, automatically it will take the frequency. Even we can set the frequency range also. If you see here, upper one, we can just define what will be our start frequency, what will be our stop frequency. So we can even define the sweep, how much long sweep we want. It starts from millihertz and it can go up till 10 megahertz. We can give a sweep up till 10 megahertz from a millihertz. So for next, we will be connecting. To do digital experiments, we have something called as
Sir, just before that start. Friends, sorry for this. I will ask one question to you, which is a basic question maybe of 10th standard trigonometry. What is sin square theta plus cos square theta, please? We know that. So we can get into that and then show the students. First of all, even engineering students, sorry to say straight this, they don't know sine wave. Teachers, 10th standard teachers, ನಾನು ಅದಕ್ಕೆ ಬಡ್ಕೊಳ್ಳೋದು ಅಪ್ಪ ನೀವು ನಾನು SSLC ಬೋರ್ಡಲ್ಲಿ ಭಾಳ ಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿರ್ತೀನಿ ನಾನು ಸೇ ಐದರ್ ಇನ್ CBSE ಆರ್ ಮೈ school education, state school educations across the country, I roam around, say that first of all they don't know what is papa sin theta mug ಮಾಡಿಸ್ಬಿಡ್ತಾರೆ opposite by hypotenuse sin theta. Are boss, show the waveforms, how the particle wheel is rotating and how that is been dissected and then put it in the sinusoidal waveform. ಅದನ್ನು sinusoidal waveform ಹೇಗೆ ಬರುತ್ತೆ and number of revolutions is the frequency. So I tell them, please do that, because many other countries are following such kind of. So we are it was there earlier when we were studying, it was there. They later on removed. ಯಾಕೆ? Reduction of the syllabus. ಮೊನ್ನೆ CET ನಲ್ಲೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಆಯಿತು. ಅದಿಲ್ಲ ಇದಿಲ್ಲ. ನಾನು ಹೇಳಿದೆ ಮೇಡಮ್ಗೆ ಅವ್ರಿಗೆಲ್ಲ ಮುಂಚೆ ಇದ್ದಾಗ ಶೀಕಾ ಮೇಡಮ್ ತೆಗಿಬೇಡ್ರಿ ಮೇಡಮ್, ಶಿ ವಾಸ್ ಆಲ್ಸೋ ಒಪೈನಿಂಗ್ ದಟ್. ಇಷ್ಟು ಪ್ಯಾರಾಗ್ರಾಫ್ನ ತೆಗೆದಾಕ್ಬಿಟ್ರೆ ದಟ್ ಈಸ್ ದಿ ಬೇಸಿಕ್ ಫಾರ್ ದಿ ಅದರ್ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ಎನಿವೇಸ್, so these are all the things that one has to go into, and I said that sin square theta plus cos square theta sine wave and sin square wave and cos square wave input, you can get the constant output like a DC.
So as sir was saying, we have something called as arbitrary waveform generator, where we can put the equation of your signal. If you want to generate a signal for your equation, you just have to type the equation, and our arbitrary waveform generator will generate that particular signal and give it to you.
Is that given by your signal, oscilloscope signal generators? They say, no, my software is developed like that. That is the kind of thing that we have to appreciate, these kind
This is the equation I have given. So it will generate this kind of a signal.
What was the equation, sir? Yeah, sir, I'm reading, sir. I'm reading.
Sine 20
Yeah.
pi t
Pi t
minus cos
cos 9 pi t. Okay. Plus tan
into
exponential
tan
minus 1.
minus 1.
Into tan exponential minus 1. E raised to minus 1. Okay.
So these kind of a signals, if you want to generate in our lab, we have to design a circuit for that. We have to design each and everything we have to calculate. Only thing is that we have to give an equation. Then our Mokugo will generate that particular signal. This signal will look like something like this. These are called as unconventional waveform. Multi-instrument mode. So I'll generate the same signal and show it to you. We have something called as multi-instrument mode. Come back. So until now I have showing you how we can use our instrument as a single instrument. Now I am showing it as what if I want to use two kind of instruments at a time. As FPGA, it can operate as a single instrument at a time, but we have given option of we can use our Mokugo as a two standalone instruments. For that, we have to go inside multi-instrument mode, which is there. Two instrument at a time, because we have two input channels and two output channels. If we had 4 input and 4 output, we would have been able to use 4 different instruments. Yeah, we have our higher version. It has Moku Pro. It has 4 input channels and 4 output channels. That is for advanced research and development. It is used by NASA.
And ISRO.
And ISRO is also planning to procure it.
I was with master control facility, Hassan.
So in slot 1, I'll be using it as an arbitrary waveform generator. Arbitrary waveform generator. And slot 2, I'll be using it to display. I'll be using it as a DSO. So I'll just say apply changes. Now it is connected inside the Moku internally itself. So we can just go inside into arbitrary waveform generator. Go to equations, where we want unconventional waveforms to be generated. For with your function generators, you can generate conventional sine square ramp or even pulse. Okay. Save. 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 Okay. On the output. ಯಾವ್ದು ಮಾಡಿದ್ರೆ ಅವಾಗಿತ್ತಲ್ಲ ಡಬಲ್ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ಕೆಳಗೆ ಬನ್ನಿ ಈ ಕಡೆ ಬನ್ನಿರಿ ಅದನ್ನ ಬಿಡಿ ಅದು ನೋಡ್ತಾ ಇಲ್ಲ ಕೆಳಗೆ ಬನ್ನಿ ಕೆಳಗಿದೆ ಮೇಲೆ ಸೆಕೆಂಡ್ ಒನ್ ಹಾಂ ಆನ್ ಮಾಡಿ ಸೇವ್ ಮಾಡಿ save means it will save the equation what we have just given, and we have output is started. Then we can come back to one case saku. We can come back to our DSO. This is the signal what we are generating. ಎರಡೂ ಅಕ್ಕಪಕ್ಕ ಮಾಡ್ಕೊಂಡು ತೋರಿಸಿ ಸರ್, ಎರಡೂ ತೋರ್ಸಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡಿ. ಇನ್ನೊಂದು ಸ್ಕ್ರೀನ್ ಇರ್ಬೇಕು ನೋಡಿ. This is what we are generating. That is what is getting displayed there. Yes, sir.
Actually limits you people in not increasing the channels. Likewise, I had a small question.
No, sir. Increasing the channels. Yes, sir.
You have the hubs, USB hubs. Since all these things are software controlled, like USB hub, you connect a hub to that one USB port. You can extend it to a number of USBs, like iPad connectors and all those things. Since all these things are software controlled, can you plan something like that? One USB is there, you can draw out of it, and that can create a small hub, and you can connect multiple number of inputs.
So when we are using FPGA, sir, there will be a certain limitations to our device. Yes, sir. Because the FPGA what we are using for Moku Go is Xilinx 7000 series. It has limitation for 2 inputs and 2 outputs only. No. When you are talking about DACs, how many DACs it has, how many ADCs it has? It has only 2 ADCs, one DAC and one ADC. So we are splitting that. So at one port we are using one ADC splitted into 2 ports, and another port we are using DAC splitted into 2 ports. That's why it can. But in our Moku Pro we are higher version of FPGA, where the DACs will be more and ADCs will be more. That's why there are only 2 channels as an input and 2 channels as the output. That's the limitation what we have with this particular FPGA. So that is why we are having only 2. The limitations is dependent on, because when you are talking about something to be taken into the digital ground, you need to have a digital to analog converter. So DAC. So we have only one DAC, which is split into 2 channels. We have only one ADC, which is split into 2 channels. So 2 analog, so it will take analog signal, it will put it in a digital format, and we will process all the things in a digital platform itself. Then we have to take the output from there, which will be in a digital format, but in a real world, we have to feed it back as an analog. So we'll be using D to A converters. So in this particular, the Xilinx has given that much provision in this particular FPGA. We have a higher version of FPGA. When we are talking about Moku Pro, we have 4 channels. So it has nearly around 2 DACs and 2 ADCs. So that's, yes. Internally, it has nearly 85,000 gates inside, sir. In that, we have used only 50% of that. 50% we left it to the client itself. If they want to do some research on our FPGA, we have given them access to our compiler. If a students want to do a project with our FPGA, they want to code something to our FPGA, so they can access in our compiler, they can write the code, they can get it compiled, they will get a bitstream, they can burn that bitstream to our Moku. So parallelly with our instrument, they can even check their project also, whether whatever the theoretically they have planned and the coding they have done, whether it is going to work in a real time or not, that also student can check. So we have given that provision also. So it is not only a multi-instrument in a single instrument, it is even customizable instrument. You can customize this particular instrument according to your need. So that is also available.
I will add one more thing, madam, I'll come back to you. I will add one more thing is that when we were going around the country for demonstrations, etc., because I'm very much inclined to this, that's why I was accompanying them. Anyways, there were so many questions from the institutions by senior professors who were day in, day out into this. They were asking so many questions about this. It is all about the cost effectiveness that these things are designed. First, like module 1, version 1.0. Version 2.0 is Moku Pro, Moku Lab. Like that it goes on. So it is all about the cost effectiveness. You remember madam asked about the gigahertz in KLE, yes, this thing. So where we could address that, she could get satisfied later on. She could get, because
we have in gigahertz, but yeah, the cost of this, imagine multiplied by 100 or 150 times. Like that will be of that. Yes.
It supports MATLAB, Python, and
yeah, it has an API support with MATLAB, LabVIEW, and Python.
How actually it is connected? How actually it gets connected with the MATLAB? Because MATLAB is so much versatile, and we can use it for design and simulation and everything. How we can interface this with that MATLAB?
We have something called as API tools in it in our particular liquid instrument site, and we are connected with MATLAB also. We are internally in connection with MATLAB. So if you want to use our Moku with the design of MATLAB, that can be done. For that, it will take a bigger session if I want to explain it in detail. So if my company will plan a kind of a 1 day or a 2 days workshop, then I can explain those things in detail, in depth. So it can be done. Parallelly, it can be used with either MATLAB or with a LabVIEW also, or with a Python also. Our MokuGo is API interfaceable with all these 3. Vivaldo is just like a compiler language, ma'am. It's a compiler platform.
Compiler language, but when we are showing this waveform and all those, like MATLAB, can we interface with the Vivardo or
that-
Xilinx of any version.
That-
because students can take care of that from.
Ma'am, if you want to program our FPGA with only Vivaldo, it won't be able to. You won't be able to do that because we have given a platform for that, and we will give access to that platform free of cost. So,
Okay, additionally,
additionally,
you will provide.
we will just, and you don't have to download that software. You will be given access through cloud only. You will be accessing our platform. You can write your coding and you can compile your coding there only. You will get your bitstream also.
Because here inbuilt FPGA is there, correct, in our device. In that, can we download the by interfacing with Vivardo or Xilinx of any version?
But on which particular whether you are using Verilog or you are using VSTL?
Verilog,
because we are using VSTL. Specifically, it is there
Only
for
for
only
RTL,
VSTL.
RTL
yes.
coding.
Yes.
Okay.
Yes.
Not Verilog.
Not Verilog, ma'am. Not till now. It's not on Verilog, but we are planning to put it on because many of the institutions ask for that. So our team is doing research on that so that it will be compatible with Verilog also. But till at this moment, it can only operate on VSTL. So if you have any coding on a VSTL, you can get it done and you can just take out the bitstream and you can burn it.
Okay. Thank you.
Yes.
So as he was telling about the cloud compile, this is our cloud compile through our website where compile.liquidinstruments.com. So if you go there, you can create your own usernames and all, and you can start with the projects. So you can create a project. So we'll just open one. Yeah. So you can create the project here, and you can write the code also.
Similarly, in a Vivaldo, what you will do, ma'am? The same thing, but it will be in a VSDL format, and after that you will compile it.
Yeah.
Yes.
Yeah.
You can burn it, ma'am.
Yeah.
Yes, ma'am. Yes, ma'am.
Cloud to here we can download.
Yes.
Customize we cannot do. Here only we can run it, and through the cloud we can download.
Customization, yeah. See, customization you can do because here the cloud, you are writing the program and you are compiling here itself and you will get a bit stream. That bit stream you can load it to our Moku device. Yeah. So like that you can do the customization.
Your PC, ma'am. You will be having a bitstream. You can directly, for loading, you won't need any internet, ma'am. Only connection between your Moco and your system should be there. That you can do. But only thing is that while connecting through RJ45, you can't load anything, ma'am. You have to connect it through C port only because data only flows through C port itself when you are interfacing with Mokugo and the system. So at that time, with RJ45, it won't happen, ma'am.
So you can see the compiling. So IP synthesis, route, and bitstream. So you'll get a bitstream here itself. So this bitstream you can save it in your system, and you can burn that one to our Moku also. Yeah. Thank you.
Okay. Any doubt till now? Okay, we will show something in digital. So for digital experiments, we have something called as a logic analyzer and a pattern generator. Here we have 16 I/O ports, which we have to define whether we want to generate a pattern and feed it to a circuit, or we want to observe a data stream which is coming out of the circuit and we have to display it. That we can define by clicking there and just defining it whether it is this particular pin will be output or this particular pin will be input. So below there you can see, if you click here, you can just our base frequency is 125 megahertz. So by using the divider, we can decrease the frequency to as much as of our requirement, depending upon the baud rate what we require. Even we can define the number of ticks also. How many ticks? If I want only 8 ticks, 10, 12, it can go up till 10,000 also. And after that, we can just edit the pattern. If we just come here and press here, we can give the patterns. We can edit the patterns, ones and zeros. So now we have connected that particular thing with the OR gate, right? OR gate we have connected, right? So we are just giving an input, we are just turning out the output. OR gate, so. ಯಾವ ಪಿನ್ ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ? 456 ಇಲ್ಲಿ 456 ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ? 456 ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ ಇಲ್ಲಿ? 1 2 3 ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ? ನೀವು ಅಲ್ಲಿ 456 ಅಲ್ಲಿ ಔಟ್ಪುಟ್ ಜನರೇಟ್ ಮಾಡಿದ್ರೆ ಹೆಂಗೆ ಬರುತ್ತೆ? 1 2 3 ಯೂಸ್ ನೋಡಿ.
ಇಲ್ಲೂ ಪಿನ್ಸ್ ಅದೇ ಯೂಸ್ ಮಾಡಬೇಕಾ?
ಹಾಂ, ಮತ್ತು ಇಲ್ಲಿ ಅದನ್ನು ಬಿಡಿ. ಈಗ ನೀವು ಜನರೇಟ್ ಮಾಡಿರೋದು ಬಿಡಿ, 1 2 ಅಲ್ಲಿ ಕೊಟ್ಬಿಡಿ. 1 2 ಅಲ್ಲಿ ಇನ್ಪುಟ್ ಕೊಡಿ ಸಾಕು. 3 ಅಲ್ಲಿ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ. ಬರುತ್ತೆ ರೀ. ಅದಕ್ಕೆ ಇದಕ್ಕೇನು ಸಂಬಂಧ ಬರಲ್ಲ ರೀ. ಇಲ್ಲಿ ಇದಕ್ಕೆಲ್ಲ ಸಂಬಂಧ ಬರೋದು. ಅಲ್ಲಿ ನಾವು ಏನು ಜನರೇಟ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ ಏನು ಚುಚ್ಚಬೇಡಿ. ಚುಚ್ಚಬೇಡಿ. ಒಂದು ನಿಮಿಷ ತಡಿ. ಇಲ್ಲಿದೆ ತಾನೇ ಎಡಿಟ್ ಪ್ಯಾಟರ್ನ್. So this is the OR gate what we have connected. So you can see here, whenever both the inputs are, these two are inputs and this is the output of a particular gate. Whenever, as per the OR gate, whenever both inputs are 0, then only the output will be 0. Be it in any other case scenario, either one of the input is high. So output is high. You can see here and the output. So similarly, we can check the gates, we can conduct the digital experiments, and we have given a protocol decoders also. If you can see here.
Some youngsters are here. Can I ask?
We have all kind of protocol decoders. For testing, it will be very.
I will ask youngsters, what is OR gate truth table? Yeah, can somebody? And don't take that. I am asking some. Yeah, please, OR gate truth table.
So protocol decoder, basically why we have given a protocol decoder, this is the same instrument which is used by Tezol to train their new employees. Our Mokugo is used in Tezol Semiconductors India Limited, who are into silica testing. So they are using our Mokugo. Basically they are using these protocol decoders because they will be working on testing of silica before it goes for post-production or a mass production. So whichever silica needs to be sent to the market, earlier it has to get tested. So that is done by Tezol, and those people are using our Mokugo, and they have been partnered in designing this hardware part of our Mokugo. So they are using it. So protocol decoder means nowadays if you go in automotive industry, if I take my car to a garage, mechanic will not come with the trenches and everything. He will come with a laptop. He will just punch in a bunch of wires and he will run some debugging codes. Then my car will be ready. Earlier time they used to use in Kannada we used to say pakkad pana hidkondu, they used to do the repairing and everything. Now it's not that. They are just using a laptop. So these protocol decoder, to understand how the protocol works, how the CCU or the communication happens in between one unit to another unit. So these are the basic protocols what we are using in our digital communication. So these will be a very important and helpful tool for students to understand also. So that is also we have provided in our logic analyzer. So we have one more waveform generator, a standalone waveform generator. For a communication engineering, we will be doing a discrete circuit for ASK, FSK or AM, FM phase modulation. In our standalone waveform generator, we have pre-modulated signal. You can directly generate amplitude modulated signal or frequency modulated signal or a phase modulated signal. So if you are doing a prototyping or if you are doing a project or if you're doing some research, these kind of tools will be very, very useful. Because every time you can't take the discrete components or you can't design everything in a MATLAB or in a simulation. Because simulation, it will be done in an ideal condition. But when we implement it in a real time, there will always be a noise. So whenever we talk about communication, there will always be a noise. So all our design and all our generation is happening in a digital platform. When the things happens inside the digital platform, the noise ratio will be next to zero. Availability of noise will be next to zero. I can't say it as a zero because noise can't be eliminated completely. It can't become a complete zero. It will be next to a zero. So it will.
Problem what we face is the very minimal level of the signal. So where I put my noise and it gets amplified, my original signal gets amplified, it goes there and then touches and then comes back with the known magnitude of the signal, and then I filter it because I know what is the noise that is been given as an input. So as sir was also saying, we filter the noise and then get the original output. This is what is happening. Image processing is one thing that very recently we have got from Chandrayaan 3. Because Chandrayaan 3, before landing 2 days, my students were unguided, my doctorate students at Indian Institute of Space Science Technology. And then 6 minutes we were given the entire module to run the satellite. 6 minutes they had given. So Indian Institute of Space Science Vikrams Sarabhai, my students developed the circuit, which was vetted in IISc, CDT as well as PEL also, and the circuit was very small because there was a problem of the weight also, measurements of this thing. So noise was the main thing that we the glide opened and then just landing before the got generated, eh?
Yes, we got generated.
Yeah, because I was making a lot of noise.
10 ಕೊಡಬೇಡಿ ಅದು 5 ಕೊಟ್ಟಿದ್ದೀರಾ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದೀರಾ 5 ಕೊಟ್ಟಿದ್ದೀರಾ ಅಂದ್ರೆ ಇಲ್ಲಿ 50 ಕೊಡಿ
Semiconductor industries are coming to India. This is what I wanted to state. Okay, so China has already outsourced number of years pilot because of some labor costs, etc. So they are number one. But this has been identified by my people around, and then they are encouraging the software, semiconductor complexes to come out, and that has been worked out in due course. So, ನಾನು ಅದಕ್ಕೆ ಹೇಳೋದು ಸಾರ್ ನೀವು ಭಾಳ ಸೀನಿಯರು ಯಾವ ಕೋರ್ಸ್ ತಗೋಬೇಕು ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಕಂಪ್ಯೂಟರ್ ಅಲ್ಲಪ್ಪ SSLC ಫೇಲ್ ಆದವರು ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಕಲಿಬೋದು ಕಣಯ್ಯ ನೀವು ಫಸ್ಟ್ ಮಾಡ್ಕೊಂಡು ಡಿಪ್ಲೊಮಾ ಮಾಡ್ಕೊಂಡು ಅಥವಾ ಇಂಜಿನಿಯರಿಂಗ್ ಮಾಡ್ಕೊಂಡು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಕಲೀರಯ್ಯ. So my electronics, instrumentation, my traditional mechatronics or mechanical, civil, all are important. Okay, so we are going away and only into ಯಾರು ಕೇಳಿದ್ರು ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್, ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್, ಇನ್ಫಾರ್ಮೇಶನ್ ಸೈನ್ಸ್ ತಲೆ ಹೊಡ್ಕೊಬೇಕು. Okay, so this my electronics kind of thing has been set aside, and my pure science, physics research ಯಾರು ಇಲ್ಲ, ಎಲ್ಲ ಅಬ್ರಾಡ್ ಹೋಗಿ. So
Sir,
ಇವೆಲ್ಲ ಕಾಮೆಂಟ್. So we are working out very hard to bring back to normalcy. People are understanding. That's why Indian Institute of Science Education Research,
ASK, we have generated ASK, amplitude shift keying. You can see there, ma'am. We are giving data. Whenever the data is high, it is passing. So without using anything discrete, we are generating. The same thing you can connect antenna to it through USB port, and you can directly transmit the signal. You can use one Mokugo to transmit and another Mokugo to receive. In between you can add the antenna, or you can do instead of sending something like this, we can even transmit a sound wave also. No, I'm just talking about you can make a radio. Maximum it can generate up till 20 megahertz. So till 20 megahertz you can have your carrier frequency. No, we can connect the antenna directly through BNC port. We can connect. It's not a radio, sir. Whatever you are doing as a AM modulated signal, you have to transmit it. To transmit, you will be using antenna, right, sir? you can take the output what is getting generated, you can just feed it to antenna. It will just start transmitting. Then you can use one more antenna to detect it, and we can connect it to our Mokugo. And using our Mokugo tools, we have different kind of tools in Mokugo. If you connect it to, you can say spectrum analyzer, you will be knowing how much, what is the frequency of, what is the bandwidth you are transmitting. In that range, you will just see the spike will come. If you set up the resolutional bandwidth and start frequency and stop frequency, you will get the peak. So you can just see how the antenna, how the transmission and receiver. So we can explain these things to students in a very much more compact manner. Even you can take the same experiment into your classroom also. They don't need to come to the lab to understand the basic principles. To understand the basic principles, they don't need to come to the lab.
My teachers,
You can just teach it in the classroom. Faculty can take the Mokugo as it's a very lightweight. You can just connect, because nowadays most of the colleges will be having a projector inside the classroom itself. So you can just project. So it will be much more easier to students to understand, and the interaction of the students or involvements of the students will be more. So they will see that something new is happening. So something new is, the way of teaching is something new is happening. So it will be fruitful for faculty also, it will be fruitful for students also. So this is how we can do the modulation communication part of the experiments.
So one small, this one. There's a small announcement. So after this session, we'll have a lunch also, followed by lunch. So lunch also is coming. So after the session, we'll have a lunch. Thank you.
ಅಲ್ಲಿ ಡೌಟ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ ಸರ್, ಕರೀತಾ ಇದ್ದಾರೆ.
It is not noise, ma'am. Just we can make it zero also. Just by ಸ್ವಲ್ಪ just zero.
40 registered, sir?
Depth. Depth of this one. Yes. If you increase and decrease, it will go. There will be some distortion. There will be some side bands. As we are using a square wave, there will always be some side bands. So we have to suppress them. No, in the circuit, that will be completely perfectly calculated things. Here you have to tune it. You can tune it as per your requirement. Also, you can tune it. Yes, sir.
So can we simulate the power electronic devices like SCR, triac, diac?
First thing is, sir, this is not a simulation, sir. This is in a real time, whatever is happening. It's
No,
an
I'm
instrument.
asking whether these functionalities are available in that Moku Go.
No, sir. Because if you have any, this is a tool, or you can say it is an instrument where you can measure the things, where you can generate some signals and you can feed it to discrete. You need to have a circuit where you have to feed and we can collect the signals.
But these are the functionalities you have added functionalities, no? Like
Which one?
for that ASK, AM and FM.
ASK,
You have not
no, it is
connected
not
a
connected to circuit.
That's what, like this, do we have that power electronic device component?
We haven't encountered because we didn't plan it for power electronics. If you can give us the input, we will take it back to our research people. We will see what, because that's why we have given something called as Mokugo cloud compiling. So we can design something and we can implement it, because 50% of our FPGA we have left it open, so that researchers can add some more applications into it which they require. So together we can plan it out with our backend research team, so we can come out with something of your requirements also. So sir will be in contact with your colleges, so you can give us the input, so we can work on that. We can work on it and we can give that. So I'm not saying it's not possible, it is possible, but it will come in a near future. Yes, ma'am. Howdu, ma'am. Circuit anthelalla, ma'am, it's just a code we have given inside. So it will align itself as a ASK. ASK ge yavatidru the equation irutte, ma'am. No, ma'am. The whatever signal you are seeing here, you can take it out and you can feed it to circuit also. This is the signal which is getting generated. ಈಗ ನೀವು ASK ಮಾಡ್ತೀರಾ ಮ್ಯಾಮ್?
Without circuit.
ಇದು ಬರುತ್ತೆ ಮ್ಯಾಮ್. ಇದನ್ನ ನೀವು ಡಿಮೋಡ್ಯುಲೇಟರ್ ಕೊಟ್ಬಿಟ್ಟು ಡಿಮೋಡ್ಯುಲೇಟ್ ಮಾಡ್ಬೋದು ಮ್ಯಾಮ್. ನಮ್ಮ ಮೊಕುಗೋಯಿಂದ ಔಟ್ಪುಟ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಇದೇನು ಜನರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅದನ್ನ ನೀವು ಡಿಮೋಡ್ಯುಲೇಟರ್ ಕೊಟ್ಬಿಟ್ಟು ಇದನ್ನ ಡಿಮೋಡ್ಯುಲೇಟ್ ಮಾಡಿಬಿಟ್ಟು ನಿಮ್ಮ ಒರಿಜಿನಲ್ ಸಿಗ್ನಲ್ನ ರೀಕ್ಯಾಪ್ಚರ್ ಮಾಡ್ಕೋಬೋದು ಮ್ಯಾಮ್. ದಿಸ್ ಇಸ್ ನಾಟ್ ಸಿಮ್ಯುಲೇಷನ್ ಮ್ಯಾಮ್. ಇಲ್ಲಿ ಜನರೇಟ್ ಆಗ್ತಾ ಇದೆ, ನಮ್ಮದು ಒಂದು ಪೋರ್ಟಲ್ಲಿ ಆ ಸಿಗ್ನಲ್ ಬರ್ತಾ ಇರುತ್ತೆ. ಎರಡು ಒಳಗಡೆನೇ ಇದೆ. Yes, ma'am. Yes, yes, ma'am. You can, if you want, you can give a message signal from outside also, ma'am. Internally, externally, you can give a message signal. That's the same thing what we did, ma'am. We took a signal generator from CRO. We have an inbuilt signal generator in CRO. We have taken a message signal from there. We have fed it to our signal generator, standalone signal generator, with the mode of amplitude modulation. So our message signal is coming from our DSO, and carrier frequency is there in our standalone waveform generator. Both are mixed, and your amplitude modulated signal is getting generated. That we are seeing it in a CRO. Or we can just feed it to next part of the circuit. We can take it from the port. Okay. You can just take signal generator only, you can directly give it. No, ma'am. If you are using it for external circuit, it will work as a signal generator. If you want generated signal, you can.
Regarding power system analysis, power systems, how do you address certain
For a power
simulation or
power
whatever,
system.
like electrical power system?
Electrical, because our range is not to that level, sir. When it comes to electrical, our range is not to that level.
Mentioned here, teach all the concepts of modern power systems from monitoring and analysis to real-time control.
If you can give me one, where
it is here.
Yeah.
That's why I'm excited to see, since I'm belong to electrical engineering.
Yes.
So how do you address
You're
this?
from electrical engineering,
Yeah.
sir. So bridge rectification is there, sir. Control system, when you are talking about lead lag networks, that we can analyze using our FRA. Depending upon your applications to applications, sir. If you tell me what kind of experiment, which experiment you want to do with our MOCU, I can tell you whether it can be done with that or it can't be done with, whether it can be realized with that or it can't be realized with that.
You deal with very high voltage like 11 kV?
No, sir. Those it will not support, sir, because ours is in the range of, because you will be in a.
Sir, I'll answer your question. You are asking about the
Power systems, power system.
analysis.
Yeah.
What can be done is we step down accordingly. Proportionality step down. That step down can be tested through the MOCU, and then it can be taken back
ಇಲ್ಲ
to the real.
ಅವ್ರು ಕಳಿಸಿ ಸರ್, ನೀವು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ತೀರಾ ಸರ್.
What I'm saying.
But
See, for example, we wanted to test the. Yeah. Exactly.
The last one.
Because these Spruha solutions are not into this kind of analysis. So they have not been trained in this. So what I'm trying to put forth is that can be done. For example, you are saying my hydroelectric or windmill powers kind of. So if I have to analyze that and then
the fault analysis.
fault analysis, etc., it can be done. How? What is that can be done? Step down. Proportionately step down, and then that K factor, yeah. That is what I'm saying. Step down.
Step
That
down
step down
the voltage has to agree
and
to
then
that.
I get the result, and then I analyze this thing. This is what our Karnataka regulatory electric regulatory commission has. So I went there, and then I took the support through online. The other guy, laboratory guy of liquid instruments, got connected. He explained, but I was not much into that. But it can be done. It can be done. It can be done. I can get the videos also if you have.
Better, like if you can get us videos and all this.
Absolutely, absolutely. So there is no. Yes, yes. So it is there. It is there already. US and then transmission systems they are using now. They are using already. They are so happy about this thing. KERC is so happy about this kind of solution where we are trying to get into that. Yes, sir. Good question. Good question. Power management is a possibility because our people are basically into smart designs and then academics. So when it comes really into the power electronics, Indian Institute of Science, they are doing this Mokugo. But we don't know. Directly liquid instruments are in connect with this thing. So they don't know. So I can take you to my IISc sometime and then take you to power electronics department itself and then make you understand how we can use these modalities into usage. That can be a possibility. Sorry? Very, very true. Very true.
So till now,
Certainly.
I showed it how we are doing a modulation. I'm just taking a AM modulated signal now. I'm using my Mokugo in multi-instrument mode. We have something called as lock-in amplifier in our Mokugo. It can be configured as a lock-in amplifier. The left-hand side, you can see that is a lock-in amplifier. Lock-in amplifier is nothing but it will lock to the phase, and in a simpler word, it will perform the function of demodulation. So we are generating an AM modulated signal. If we can get inside our lock-in amplifier, so this is our lock-in amplifier. Here we have channel A input or channel B input, whatever the input what we are going to give. Here the mixing of the signal will happen. Here we have local oscillator. So it will lock to the carrier frequency of the modulated signal. So this locking and everything will happen in this part. If you see these dotted points here, if we press here, we have integrated a DSO here. If you just press here, it will open up a window which will show integrated DSO here. So it will show the signal which is at that particular point. So we have taken a carrier frequency of. So we will set our local oscillator to 10 kilohertz. So if you see here, at this probe point, you can see the rectified half the signal, positive or negative, both are available there. So similarly, in our demodulator, we will be using a low pass filter after the rectification or a half wave rectification. So this is a low pass filter. We will set, here you can see dB by octave. That means we can define the order of the filter, in which order we want. It starts with the second order, it goes up till sixth order. So 24 by dB octave. So after that, if you can just see here, this is the output. Change the frequency. Not 40. 1. Go to 1. 1, 1, 1, 1. ಏರಿಸ್ತಾ ಹೋಗಿ. ಹೆಚ್ಚಿಗೆ ಮಾಡಿ. So you can see the frequency here. Our message signal or FM is 1 kilohertz. So this is the demodulated signal. Yes, sir.
That we can do. Can you just show me the waveform on the screen?
That I can do.
Please.
I will do that. So sir has asked us one query, whether we can take a live speech. For that, we will do a small experiment. So I'll give my phone number to you, sir. You give me a ring. I will just connect my phone to my Moku. In our Moku, we have some system development tools. If you come back to main menu, something called as digital filter box or FIR filter box. So if I want to apply different kinds of filters, be it IIR filters or FIR filters, so I'll be using this tool. So what we will do, we will just connect it to sir. Sir will be giving me a call. I will connect it to Moku and we will send the signal through our digital filter box. After that, whatever the output will come, that we will connect to speaker. So we will see what kind of output is coming and we can even show the signal and we can hear the signal also. Okay, we will just give me 2 minutes so that I can get it set it up. ಸ್ಪೀಕರ್ ತಗೊಳ್ಳಿ ಎಲ್ಲಿದೆ ಸ್ಪೀಕರ್ ಎಲ್ಲಿ ಮೈಕ್ ಬರಲ್ವಾ ಮಲ್ಟಿ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಮಾಡಲ್ಲ ಡಿಜಿಟಲ್ ಫಿಲ್ಟರ್ ಬರ್ತದೆ ಬೇಡ ಬೇಡ ಮಲ್ಟಿ ನಾನು ಕ್ಲಿಯರ್ ಮಾಡಿದ್ದೆ ಇಲ್ಲೊಂದು ಸೌಂಡ್ ಬರ್ತಾ ಇರುತ್ತೆ ಸರ್ ಮೈ ನಂಬರ್ 9110 110 0678 9110 678 042 42 yes sir point probe ಮಾಡಿ ಅದೇ ಮೊನ್ನೆ ಸರ್ ಮಾಡಿದ್ರಾ ಸರ್ ಫಾಲೋ ಹಲೋ ಅಂದಾಗ ಸರ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಬರುತ್ತೆ ಸ್ವಲ್ಪ ಚಿಕನ್ ಓಕೆ ಸರ್ ಇವಾಗ ಸರ್ ನಾನು ಸ್ಪೀಕರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೇನೆ ಸರ್ ಓಕೆ ಫಿಲ್ಟರ್ ಹಾಕಿ ಓಕೆ ಫಿಲ್ಟರ್ ಹಾಕಿ ಓಪನ್ ಮಾಡಿ ಸೊ low pass filter ಹಾಕಿದ್ದೀವಿ ಸರ್ we just applied a low pass filter we have taken 10 kilohertz so it will pass the frequency till 10 kilohertz ಕಟ್ ಮಾಡಿದ್ರಾ ಸರ್ ಕಟ್ ಮಾಡಿಲ್ವಲ್ಲ ಹೇಳ್ದಂಗೆ ಮಾತಾಡೋರು ಅಂತ ಸರ್ so low pass filter with Butterworth filter with order 12th order we can change the order also we can change from filter to filter now we are using low pass filter ಅಲ್ಲಿ ಮೇಲಿದಕ್ಕೆ ಬಂದ್ಬಿಡಿ ಫಸ್ಟ್ upper one full we can either use low pass, high pass, band stop, custom. So whichever filter we want to apply, we can apply to that particular sound or wave what we are giving. So we are using low pass. So we are using low pass. Here we can just select which type of a filter we want to give. Butterworth, Chiveshu 1, Chiveshu 2, any kind of a filter you can directly apply. Okay, keep it in a Butterworth only. Keep it in a Butterworth only. Okay, just cancel it. You just close it. So just we are going to turn on the output. Sir, now you talk, sir. It is connected to speaker here. You can talk, sir. Call cut ಮಾಡಿದ್ರಾ ಸರ್ ಮಾಡಿ. 1 ಮಾತಾಡ್ತಾರೆ.
ಹಲೋ
ಮಾತಾಡಿ.
ಹಲೋ ನಾನು ಎಲ್ಲರಿಗೂ ಈ ಒಂದು ವರ್ಕ್ಶಾಪ್ಗೆ ಸ್ವಾಗತ ಕೋರುತ್ತಾ ನಾನು ಈಗ ಹಲೋ ಬಂದೆ ಈಗ ಒಂದು ಪದವನ್ನು ನಂಗೆ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಎಲ್ಲರೂ. ಒಂದು ಕನ್ನಡ ಪದ ಕಂಟಿನ್ಯೂ ಮಾತಾಡ್ಕೊಂತ ಹೋಗ್ಬೋದು ಸರ್. ಓಕೆ.
ಸಿಮಿಲರ್ಲಿ ನಾನು ಈಗ ಡಿಫ್ರೆಂಟ್ ಕೈಂಡ್ ಆಫ್ ಫಿಲ್ಟರ್ಸ್ ಹಾಕ್ತೇನೆ ಸರ್. ಐ ವಿಲ್ ಜಸ್ಟ್ ಡೂ ಏನು ಮಾಡ್ತೀನಿ ಸರ್, ಇದರಲ್ಲಿ ಮ್ಯೂಸಿಕ್ ಹಚ್ಚಿಬಿಡ್ತೀನಿ ಸರ್ ನಾನು. ಸೊ ಮ್ಯೂಸಿಕ್ ಮೇಲೆ ನಾವು ಡಿಫ್ರೆಂಟ್ ಕೈಂಡ್ ಆಫ್ ಫಿಲ್ಟರ್ಸ್ ಹಾಕೋಣ ಸರ್. ದೆನ್ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಎಫೆಕ್ಟ್ ಇನ್ ದ ಸ್ಪೀಕರ್.
So using this one instrument, you can cover all your electronics lab. You can work on analog lab, you can work on digital, you can work on communication, signal processing, as well as PID control systems, and FPGA also.
Now we will apply different kind of filter. Now we have applied. We will just change the cutoff frequency. We will just vary it. You can see the variation in the sound. Immediately we are going to change it from low pass filter to band pass filter. Band pass filter. Band pass. You can just focus on a particular band in our particular signal what we are giving. So to do the similar experiment in our regular lab, we need a different kind of lab setups, discrete components, when we have to think about the noise it will generate. So this is when you are doing projects or when you are doing research, at certain point you will be stuck up with the corrupted signal, or you can say a mixed signal, and we need to apply different kind of filters. So this tool, if you use this tool, it will be very time saving also. You can design the particular filter what is required there. After when you get the cutoff frequency and which type of filter will be much more suitable, the same thing you can implement in your project itself. So it will be very good tool for research. So for this is our digital filter box is for IR filters. We have a similar thing for FIR also. You can see here the same. Here we have a different kind of FIR filters. When you get into the filter box. So make it in a time domain. Shapes, come into shapes, illy. You can give the equations also here for your filter. For a shape of your coefficients, you can give equations also. Similarly, as we did it in arbitrary waveform generator, we will be having an equation for your filter. You can just feed the equation, it will generate the filter of that kind. You have all types of windows available here. Barrett, Han, Hamming. So doing digital signal processing or DSP lab also, it can be covered with our Mokugo. So signal processing also can be done with our Mokugo. So it is not just one instrument. It is a complete solution for electronics engineering, even instrumentation engineering, a bit part of electrical engineering, and even power electronics also. But majorly in electronics engineering, if you want to make a student to understand how life cycle, or you can say how a design cycle of an instrument can be done, you can start with telling them to make a particular design in their head, or some idea in their head. So we have given option to use our FPGA also, if they can develop something, the program in their head, and they can write it and they can burn it and they can check it, whatever the idea they have made for the instrument of their own, whether it will be working in a real time or not. So by the time they finish up their engineering, they will be learning each stages of how the product is developed using our Mokugo. That's one more advanced level of using our Mokugo, or it can be used for your regular labs also. Not only any specified labs, you can use it for regular lab. And it's a very rugged model, and it's a very lightweight, and it doesn't require calibration. That's a major part here. It doesn't require calibration. It's just a one-time investment. And in future, if there will be more instrument which will be added to our Moku series. So only thing is that you need to update the software. Every time it will send for the updates, you need to update the software. The new instruments will be added. So this is all about from our end. If you still have any doubt, I am just open for questionnaires. So if you want to know something more, or what kind of support, what kind of other things we can add, like sir said, something about power electrons we can add, we'll get back to them, we'll get in touch with them. So if we can do something about that, we will do something about that also.
I have told sir about my Indian Institute of Science using in the power electronics department itself. So we can make a visit there, and then I can give the connectivity, or I can also come there sometime whenever you are planning. And you can see how they are using this. In fact, so many instruments they have replaced. Ella tavano store room alli ittibididare. Except this Moku Pro, Moku Lab ni itkonbittu mikidella olagade ittidare. So they are doing a lot of experiments. Yeah.
So this is all from my end till now. So if you have any doubts, any instrument you want me to explain again, so you can just ask me, I will do that. These are all the instruments which are present. We did not explain about these projects, this one particular instrument and this one, phasor meter and laser lock-in box. Laser lock-in box is majorly used in optical communication kind of a thing, where you will be locking the axis of the laser. So in UG level, we are not teaching up till that, because we don't have a lab till there. Even a phase meter also we are not even a spectrum analyzer also. When I was doing my engineering, I didn't see spectrum analyzer at that time also. I think so the same thing is happening now also. So these are exclusive kind of a things which will be much more useful in, like ISRO is using in Moku Pro, because the range of specification of Moku Pro will be a bit higher. So in the lower range, you can just understand the principles of it, but the instruments what are used to measure phase meter, use phase meter and laser lock-in box, that specification will be a bit higher. So that's why we didn't explain about these two instruments. Other than that, all the instruments we have covered. So if you want to continually collect the data and save it, you can use data logger. As you know, data logger is to continually collect target data which are connected to sensors.
I will ask one question. In the traditional way, how are you going to do the experiment and then collect the data and note down? How was the procedure that you are following in your laboratories, please? Can somebody explain? Yeah. Traditional, using oscilloscopes, etc. Data, how you are going to collect and then do the recording, recording the data, how you are doing? Sorry? Correct. So this is the advantage here. That's what I mean. You can store the data, and any given time you can recap, and you can redo that and arrive at your.
Yes, sir. It is a solution. It is a DSL. So that is the advantage here. So it can even work as, why I am saying data logger. Data logger, when you are connected to some, you
can say some sensor. I have connected it to temperature sensor, and I don't want to sit in front of my PC to continuously check whether it is getting recorded or not. You just set a time frame for 1 hour, 2 hours, 10 hours, 24 hours. So it will be loading. It will be recording that data. So it will be storing in your system. After that, you can recall the data in a particular point of time. If you want to see the data at 6th hour, if you want to see the data at 12th hour, you can do those things. For that, data logger service. So you don't need to have a separate data logger. I showed you, sir. If you want to use two standalone instruments at a time, then we will be splitting our FPGA into two. The capacity of the storage will be done in your PC. Whatever the storage capacity is there in your hard disk, that's the same storage capacity. Because it will not be using any internal memory inside the boot. It will be using a memory where you specify where it needs to be stored. Either you can store it in cloud also, or you can store it in your PC. Your cloud. If you have your cloud, if you want to store it there, you can store it there also. Or if you don't want to store it there, you want to store it in your hard disk, you can store it in your hard disk.
So, how about the phase meter? What is that phase meter?
These two instruments we haven't touched because this is not.
Sir, I will tell you, sir. Phase meter is what my people are. It is all about lag leads in the voltage and current, where you know very well. That is very highly beneficial to know the pattern of the production, where why how inductance load is high or capacitance load is high. So how we can get into power systems. So this again my electrical engineering department, Tata Institute, they are using my liquid instruments. My friend doesn't know about that. Anyways, I am just stating. I know your this thing. When you said electrical, I could map your this thing. Because one day first year I electrical ಇರುತ್ತೆ. ಆಮೇಲೆ ಒಳ್ಳೆಯವರು ಇನ್ಸ್ಟ್ರುಮೆಂಟೇಷನ್ ಬಂದ್ಬಿಡೋ ಅಂತ ಕರ್ಕೊಂಡ್ಬಿಟ್ರು. ಸೊ ಹಾಗಾಗಿ ನಮ್ಗೆ electronics and instrumentation. Signals and systems, Raghu, where is Raghu? Yeah, please come, Raghu. Signals and systems, Ramchandra, ಅಪ್ಪ ಸ್ನೇಹಿತರು ನೀವೆಲ್ಲ ಹಿಂದಿರ ದೂರ ಇದ್ರೆ ಕಷ್ಟ ಆಗತ್ತೆ, ಹತ್ರನೇ ಇತ್ತು. We were, given the subject of signals and systems in second year instrumentation. Although ours was instrumentation, communication, signal, electronics and instrumentation guys were having the third year. Signals and systems. We were going and quarreling. Namaga hakide, now instrumentation nodugro. Namak second year hakide. 14 subjects we had in the second year. We were reading up to 1 ಗಂಟೆನಾ 2 ಗಂಟೆವರೆಗೂ ಓದ್ತಾ ಇದ್ವಿ. Millman Top and what is the other signal system? Simon Hiking. We were going through, even today I have that book.
Millman Top,
Pulse and Digital. So, now why we were discussing is that those were the days where we were only depending on the books and then libraries. Indian Institute of Science, I was getting some, because my sister was there and then I was in CEDT kind of. So, he used to get from his Raman Research Institute. Our man used to go and then eat the head of my Professor Rolla and get the library books bought from the stores and then get it to the library, etc. So, what is that I was about to state is that ultimately we are winding up the program. I hope the feedback forms have been given everybody. Okay. Anyways, whatever feedback is what they will pull up and then they will digitize them. Okay. Yes, thank you. Now, friends, I would like to close up this session stating once. Can I say? Yes. Can I? Yeah, we will. I will just state one thing, that one of the days, Einstein was invited by, the professor, the vice chancellor, to his university. He said, sir, there is one big program that's going to happen, so you have to be the chief guest. He said, hey, I don't know about my calendar. So go to my secretary and then ask her. They went to the secretary's room and then they found his calendar. And the coming month's 11th day was the availability. So they marked that date and they said, madam, we are okay with this date. And all, registrar and vice chancellor both had gone, they decided. They came back to the laboratory and they said, sir, we have, noted down the dates. I don't know, she will intimate me, please, don't disturb me, because I am doing my experiment. Thank you, he said. These people felt that the day occurred. What do you mean by the day is, 11ನೇ ತಾರೀಕು ಬಂತು. ಬಂದಾಗ our man came, the driver, chauffeur, every day's a driver, came to the house of because it is his regular job to pick up, pick him up and then take to the place for the function. Door was not getting open. That was not the habit that he used to experience. Every day, the moment the driver comes, by hearing the car sound, our man used to come out with his normal attire and come out and then sit in the car. That day it did not happen. It was very peculiar for him. Then he thought, something would have happened. Then he went and then pressed the calling bell. Did not open. Then he knocked the door with that this thing. Chilka hodadru tegililla. He got worried. ಸಾಹೇಬ್ರಿಗೆ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ ಏನು ಎಷ್ಟೊತ್ತಾದ್ರೂ ತೆಗಿತಾ ಇಲ್ಲ 5 ನಿಮಿಷ ಟೈಮ್ ಬೇರೆ ಆಗ್ತಾ ಇದೆ ಐ ಹ್ಯಾವ್ ಟು ಗೋ ಟೇಕ್ ಇನ್ ಟು ದಟ್ ಫಂಕ್ಷನ್ ಪ್ಲೇಸ್ ವಿಚ್ ಇಸ್ 30-40 kilometers away from the regular laboratory. So he was very much worried. So he was about to go to the back door, then the door got opened. Our man was in the night gown itself, night dress itself. Then he said, sir, why sir you are not ready? And it is so important thing was that they both look alike. ಇಬ್ರು ಒಂದೇ ತರ ಇರೋರು. ಜೋಸೆಫ್ ಅಂತ ಡ್ರೈವರು, ಇಬ್ರು ಪಕ್ಕದಲ್ಲಿ ನಿಲ್ಸಿದ್ರೆ ಐನ್ಸ್ಟೈನ್ ಯಾರು ಜೋಸೆಫ್ ಯಾರು ಗೊತ್ತಿಲ್ಲ. ಇಟ್ ಮೇ ಬಿ ಎ ಮೈಥಾಲಜಿಕಲ್ ಸ್ಟೋರಿ ಆರ್ ವಾಟ್ ಎವರ್. ಐ ಆಮ್ ಜಸ್ಟ್ ಸ್ಟೇಟಿಂಗ್ ದಿಸ್. ಓಕೆ, ನೌ ದೇ ನೋ. ಓಕೆ, ನೌ ವಾಟ್ ಹ್ಯಾಪೆಂಡ್? ದಿಸ್ ಮ್ಯಾನ್ ಗಾಟ್ ವರಿಡ್. ಏನಪ್ಪ ಇನ್ನು ಗೌರ್ನಲ್ಲೇ ಇದಿರಲ್ಲ ಸರ್, ವೈ ಆರ್ ಯು? ನೋ, ಯು ನೋ ವೆರಿ ವೆಲ್ ದಟ್ ಯೆಸ್ಟರ್ಡೇ ಐ ಹ್ಯಾಡ್ ಫೀವರ್. ಯು ಓನ್ಲಿ ಬ್ರಾಟ್ ದ ಡಾಕ್ಟರ್ ಬೈ 10 o'clock, got me injected, and then why are you disturbing? Yeah? He said, sir, we have to go to the program. World over scientists have come. Let us not waste time, sir. Please get ready. I will take you safely and bring you back. That is my vada. Okay? So, ಇವನು ತಲೆ ತಿಂತಾನೆ ಅಂತ ಇವ್ರೇನು ಮಾಡಿದ್ರು, give me 5 minutes, ಹೋದ್ರು, got refreshed himself, went, came back, and then he sat in the car. When car was about to reach the university gate, this man said, sir, then Einstein thought, tirga eno tarle ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Hey, what is that? Yeah, can we exchange the seats? What did he say? Exchange the seats. What do you mean by that? You become the driver, I will become Einstein, and happily you just park the car, be there, or some AC or the front row they would have given, you be there happily, and then I will participate in the program. And it was such that this man is so profound in repeating whatever the earlier seminars happened. He used to repeat the same thing. Maggodange in the car alla our program attend ಮಾಡಿ ಬಾಯ್ಪಾಠ ಆಗ್ಬಿಟ್ಟಿತ್ತು. ಆದ್ರೆ ಅವನ SSLC ಕೂಡ ಪಾಸ್ ಆಗಿಲ್ಲ. ಯಾಕೆ ಅಂದ್ರೆ ಅವನು ಬಾಯ್ಪಾಠ ಮಾಡ್ಬಿಟ್ಟಿದ್ದ. ಅವ್ರು ಕೇಳಿಸ್ಕೊಂಡು ಅಷ್ಟು ಫೋಕಸ್ ಆಗಿ ಅವನು ಕೇಳಿಸ್ಕೊಂಡಿದ್ದ. ಎಸ್ ಸರ್, ಐ ಆಮ್ ಥ್ರೂ ಸರ್, ಆಗೋಯ್ತು ಸರ್. Yeah, we will call them. Yeah. Okay, so I'm completing this in 2 minutes. You can count down. Yeah. This man thought, hey, this is going to be a problem here. What is that? Yeah, sir, we will exchange the seats and then I will take care. This man, Einstein, was very confident about his driver. So they exchanged the seats, entrance of the university gate. Then the car was driven by Einstein. And at the back, alias Einstein was sitting, Joseph. Then the vice chancellor, everybody were waiting. They opened the door. They garlanded. Whom they garlanded? Okay, Joseph. So they took him to the room, and then snacks or whatever tea or whatever happened. They took him to the podium. Program happened. Introductory happened, and he was felicitated in the auditorium in front of so many people, audience. Then ultimately that anchor announced the time. Now we are waiting for the professor to give a lecture. Our man was sitting like this. He came very hundatanavage banda mic toganda hodada lecture 1.5 hours non-stop. Fantastic. Our man was very confident. He was almost he was sleeping because he knows that he will deliver. Okay, now there was a loud applause and function almost through. The anchor came and then she thanked, and she was about to call somebody to give the word of thanks. Adu iruttalla protocols, word of thanks, etc., etc. From the left hand side of the audience, 3 people raised their hands, scientists. They said, excuse us. In those days, there was no cordless mic. Then anchor called, yeah, please come down. People came and then they said, in your agenda, program agenda sheet, there is a, last thing that before the vote of thanks, question answer session. So we have to ask some questions with the professor and we have to get clarified with that. Can we ask? Then the anchor turned towards him. He was again, doing like this. ಕಾಲ್ ಇಟ್ಕೊಂಡು ಹಿಂಗೆ ಎಲ್ಲ ಆಡ್ತಾನೆ ಇದೆ. ಅವರು ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ರು. ಯಾವ ಕ್ವೆಶ್ಚನ್ ಆನ್ಸರ್ ಸೆಷನ್ ಅಂತ ಬಂದಿದ ತಕ್ಷಣ ಬೆವರು ಬಂದ್ಬಿಡ್ತು ಅವ್ರಿಗೆ. He was about to fall. Our Einstein in the front row. ಅವ್ರಿಗೆ ಬೆವರು, ಅಯ್ಯೋ ನಾನು ಇದು ನೋಡೇ ಇಲ್ಲ, ಇದು ಇದ್ದಿದ್ರೆ ನಾನು ನೋಡಿದ್ದಿದ್ರೆ I would have not accepted this deal. Anyways, it is out of my hand now. So he was about to observe what this fellow is doing and ಕೋಪನೂ ಬಂತು ಅವ್ರಿಗೆ. ಏನು ನೋಡೋ ಅವನಿಗೆ ಎಷ್ಟು ದಿಮಾಕು ಕಾಲು ಅಲ್ಲಾಡಿಸ್ತಾ ಇದ್ದಾನೆ, ನಾನಿಲ್ಲಿ ಬೆವರು ಸುರಿಸ್ಕೊತಾ ಇದ್ದೀನಿ. Then when anchor asked, he said, yeah, please, they can go ahead with the questions. Then the first scientist took the mic and then posed one question which he noted down. Our man Joseph noted down. Then the mic passed. Second question noted down. Third question noted down. Then anchor called. Professor came to the podium. He straight away said, fantastic function. Okay, fantastic seminar. Never I thought that there will be a question answer session. This is what it should be. There should be a lot of questions. That's what I said. Please come out with the questions. In fact, I told my directors and all before the program that please inform them to get with the questions by going through whatever. Even now also you can browse and then hit him with the bullets. Okay, yeah. Anyways, so he said this is a fantastic scenario of getting into the question answer session. Okay, now my first question, second question, third question, it is anyway so simple that even my driver can answer. Can I call my driver, please? What happened now? ಆತ ಯಾವಾಗ ಬಿದ್ದೋಗ್ಬಿಟ್ಟಿದ್ರು, ಕಣ್ತಿರುಗಿ ಕೇಳಿಸ್ಕೊಂಡಿದ ತಕ್ಷಣ ಓಡ್ ಬಂದ್ರು, ಜ್ವರ ಎಲ್ಲ ಹೊಟ್ಟೋಯ್ತು. He came running, took the mic, it was his subject, he explained, maybe he took 40 minutes or whatever, came to the board and then he wrote all the diagrams, he explained, and then there was a standing applause. ಈತ ಹೇಳಿದಾಗ ಲೆಕ್ಚರ್ ಮುಗಿದಾಗ ಕೂತ್ಕೊಂಡು ಚಪ್ಪಾಳೆ ತಟ್ಟಿದ್ದು. ಇವರು ಡ್ರೈವರ್ ಆನ್ಸರ್ ಮಾಡಿದ್ದು, ಡ್ರೈವರ್ ಅಂದ್ರೆ ಯಾರು, ನಿಂತ್ಕೊಂಡು ಚಪ್ಪಾಳೆ ಹೊಡೆದ್ರು. ಆಮೇಲೆ ಅನ್ಕೊಂಡ್ರು, ಅಲ್ಲಪ್ಪ ಡ್ರೈವರ್ಗೆ ಆನ್ಸರ್ ಮಾಡಕ್ಕೆ ಇಷ್ಟು ಗೊತ್ತಾಗಬೇಕಾದ್ರೆ ನಿಜವಾಗ್ಲೂ ಅವರೇ ಮೈಕ್ ಅವರೇ ಆನ್ಸರ್ ಮಾಡಿ ಇನ್ನೆಷ್ಟು ಚೆನ್ನಾಗಿರೋದು ಗೊತ್ತಿಲ್ಲ ಅಂತ ಜನ ಹಂಗೆ ಅನ್ಕೊಳಕ್ಕೆ ಶುರು ಮಾಡಿದ್ರು. ಎನಿವೇಸ್ ಆ ಪ್ರೋಗ್ರಾಮ್ ಆಯಿತು. ಆ್ಯಂಕರ್ ಥ್ಯಾಂಕ್ಡ್ ಅವ್ರನ್ನು ಡ್ರೈವರ್ನು ಫೆಲಿಸಿಟೇಟ್ ಮಾಡಿದ್ರು. ಯಾರು, ಐನ್ಸ್ಟೀನ್ನ. ಸರಿ ಬಂತು. ಆಮೇಲೆ ಇವ್ರು ಹೋಗಿ ಕಾರ್ ತೊಗೊಂಬಂದ್ರು. ಅಲ್ಲಿಂದ ಆಚೆ ಬಂದಾಗ ದೇರ್ ವಾಸ್ ಎ ಟ್ಯಾಪ್ ಫ್ರಮ್ ದ ಬ್ಯಾಕ್. ಹೂ ಟ್ಯಾಪ್ಡ್ ಹೂಮ್? ಬ್ಯಾಕ್ ಸೈಡ್ ಇಂದ driver tapped Einstein because Einstein was driving the car. Then he turned, said, hey, what is that here, Joseph? Sir, I promised you that I will take you home back safely. Can we exchange the seats? ನನ್ನ ಕೆಲಸ ಅದೇ ತಾನೆ, ನಿಮ್ಮ ಡ್ರೈವರ್ ನಾನು. Please, can we exchange the seats? Then he said, hey, it is my privilege to take you back. ನೀನು ಅಷ್ಟು ಚೆನ್ನಾಗಿ ಹ್ಯಾಂಡಲ್ ಮಾಡಿದಿ. You handled the situation very, very correctly. Okay, so therefore I have that privilege taking you back. ಏನು ತೊಂದರೆ ಇಲ್ಲ ಕಣ, ಕೂತ್ಕೊಳ್ಳ, ನನ್ನ ಮನೆಯವ್ರಿಗೂ ನಾನೇ ಡ್ರೈವ್ ಮಾಡ್ತೀನಿ. See, I'm just saying, maybe a mythology would have happened or not happened, some story behind this, etc. But there are some life stories which are real, where my, you go to Mythic Society library, there are real stories that would have, ಮೊನ್ನೆ ಅಮ್ಮ ಬಂದಿದ್ರು, ನನಗೆ ಗೊತ್ತಿಲ್ಲ, ಸೆಕೆಂಡ್ ರೋನಲ್ಲಿ ಕೂತಿದ್ದಾರೆ, ಸುಧಾಮೂರ್ತಿಜಿ. ಅದು ಆರ್ಕಿಯಾಲಜಿ ಡಿಪಾರ್ಟ್ಮೆಂಟಿಂದ ಡೈರೆಕ್ಟರ್ ಜನರಲ್ ಬಂದು ಲೆಕ್ಚರ್ ಕೊಡ್ತಾರೆ. ಈಕೆಗೂ ಆರ್ಕಿಯಾಲಜಿಗೂ ಏನು ಸಂಬಂಧ? ವಾಟ್ ಎ ಲೇಡಿ, ಶಿ ಇಸ್ ವೆರಿ ಬಿಸಿ ನಾವು. ಓಕೆ, ಬಿಕಾಸ್ ಆಫ್ ರಾಜ್ಯಸಭಾ ಎಕ್ಸೆಟ್ರಾ. ನೋಡಿ ಸಬ್ಜೆಕ್ಟ್, ಅದಕ್ಕೆ ನಾನು ಹೇಳೋದು ಈ ಥರದ್ದೆಲ್ಲ ಸ್ಮಾಲ್ ಸ್ಟೋರೀಸ್ ಎಲ್ಲ ಇಟ್ಕೊಂಡು ಕ್ಲಾಸ್ ರೂಮ್ಸ್ಗೆ ಹೋಗಿ, ಆಮೇಲೆ ಸರ್ಕ್ಯೂಟ್ಗಳು ಶುರು ಮಾಡಿ, ಆಮೇಲೆ ವೈಂಡ್ ಅಪ್ ಅಂಡ್ ಸಿ ದ್ಯಾಟ್ ದ ರೆಸ್ಪಾನ್ಸ್ ಆಫ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ವಿಲ್ ಬಿ ವೆರಿ ವೆರಿ ಹೈ. ನನ್ನ ಸ್ಟೂಡೆಂಟ್ ರೇಷಿಯೋ ನಾನು ಹೋದರೆ ಸೈಲೆಂಟ್ ಎಲ್ಲ 2 hours IIT ನಾನು ಕೊಡ್ತೀನಲ್ಲ, 2 ಎಲ್ಲ ಹೆಂಗೆ ಕೂತಿರ್ತಾರೆ ಅಂದರೆ, ಆಮೇಲೆ ಡೌಟ್ಸು, ಇಂಟ್ರಾಕ್ಷನ್. ನಾನು ಹೇಳ್ತೀನಿ, ಎಸ್ 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 ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಈಗ what I'm saying is, no, she is trying to ask me whether, outside park my duplicate or triplicate, I don't. Anyways, no, what I'm trying to put forth is, get updated before going to the class. This is what, because I've worked with Kalani for some number of years with him in so many circuit designs, etc. Please, always he used to say that, please get into the dayas with all preparations, updated. Somebody was asking, sir, machine learning and AI, can it be used here? It can be. That's what I said, because these are the kind of questions that students will ask. So they are ready to get into those kind of modes and then try to note down and address what can be actually be asked by the students. You please be ready. Now, thank you. Somebody will be addressing from. Yeah, please. I would request the people from planetarium. Sir, is there? And then. Yeah, please, please. I forgot his name. Yeah, I met him sometime. What is his name? Anandji. Yeah, I met him. Very recently, Indian Institute of, this track, I took Ramakrishna. I did not know that he was my comparator. And he was the classmate of Raghu. He was classmate of this Nagendra, our classmate Nagendra. MA Polytechnic student, fantastic. See, he did that and then did BSc and then entered into engineering. And now he is the track director. He got very recently retired, a month ago. I took him to Sri Siddhartha School of Engineering, which belongs to Dr. Parmeshwar. He said, sir, I want the people from only ISTRAC, our minister said, because he's trying to come out with one observatory. He wanted to take a consultation of these people. So that way, Anandji, please sir, please. That is our privilege. No. Fantastic, very nice. Sir, please do come. Please, you have to come. Dr. Anand is here, so I did not have to say the profile of these great people who are into taking care of this planetarium and then giving the know-how of the space, mission to the children and then doing a lot of jobs. Sir, if you can address that.
First of all, welcome to Planetarium, to Manodal here present, and also I think you had a very good time looking at the demonstrations and the explanation that was shown to you. I hope you have enjoyed these sessions. And one more thing that I need to, as a representative of the planetarium, I need to say, there are many programs that we conduct for both the school going the students of many sectors like high school, whether they may be belonging to high school or the PUC or undergraduate. We have many programs that we do under the non-formal education program. And other than that, we have also many programs for the popularizing science program activities. Like our Sky Theatre is one of the flagship programs. And also we have many programs like lecture series and other things. So there are many programs that will be happening. Last Sunday, we concluded a program which is called as the Dasra Lecture Series, where we invited an eminent scientist from all over India, and we asked them to give a lecture on the hot topics and very needful topics. Right? So we concluded that program last week. So tomorrow there will be a program, right? It's also another conclusion program of the state level quiz program that we are conducting for all the government school students, right, all over Karnataka. So it will be held tomorrow here. The last round will be held here tomorrow. So there are many programs that we do for popularizing the science and also the non-formal education program. I urge you to visit our website to know more about our programs. Definitely there will be many programs that will be of your interest. So not only for the kids or the children, we do these programs. We also do for science enthusiasts who are interested in knowing about the science and astronomy in particular. So if you are interested in any of these things, please visit us, and definitely you will find at least some of the programs very interesting to you. Thank you very much. Thank you for being here and being associated with these people today. On behalf of Jawaharlal Nehru Planetarium, I once again thank you for being here. Thank you.
Okay, good afternoon. So thank you very much. You all participated today for this program demonstrations they have done. As already told Mr. Anand, this Jawaharlal Nehru Planetarium is mainly science popularization and non-formal education we are conducting here. And Jawaharlal Planetarium was started with our director, Sir C.V. Vishweshwara from the beginning. And then at that time, your president was Sir U.R. Rao, and we will also constructed in the other side. It has been named as U.R. Rao Bhavan, and also auditorium is named as Sri Vishweshwara Bhavan. Lot of activities here in Jawaharlal Nehru Planetarium is being conducted as a told for children from the nursery level to the top level college and just 8, 9 students and all. Apart from that, Karla Pravasa and so many things we are conducting here. And okay, thank you very much for all these things. My name is Dinakara, I'm an administrative officer here. And you're all from different this one or?
Yeah, they're all from engineering diploma and engineering colleges, government engineering colleges, all government segment professors and teachers, associate professors. Some of them done the doctorates and many of them are lecturers of technology per se. Yeah, sir, please. Honestly, please.
Yeah, our present director is Dr. P.R. Guru Prasad. He is engaged with other officials, but so he could not able to come now. And our chairman is Sri A.S. Kiran Kumar. He is the Bangalore Associate for Science Education Council and our chairman also for this Jawaharlal Nehru Planetarium. Thank you very much.
Sir, please. నాకు ಗೊತ್ತು ಪ್ರೋಟೋಕಾಲ್ ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಲ್ಲ ಸರ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಬನ್ನಿ ಸರ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಜಿ ನಮ್ಮ SJP
ಸರ್
ಸರ್ ಬನ್ನಿ
request Ravi Shankar sir to honor Mr. Anand sir.
Side in.
Yeah, sir. चक्षुर्देवहितौपुरस्तात् शुक्रमुच्छरद् पश्येव शरदशतं जीवेव शरदशतं शृणुयाम शरदशतं स्याम शरदशतं
ॐ चक्षक्षत्रस्य राजा वरुणोऽधिराजः नक्षत्राणागं शतभिषक्प्रसिद्धः तौ देवेभ्यः कृणतो दीर्घमायुः.
Thank you. I know, sir, I can do it. What is that? Yeah, I know biological cells, okay, the primary cells, which are the building block of this thing, will not listen. So, and you know, the other thing also is ready. So, give us only maybe maximum 5 minutes, and you know, sorry, you have to issue the certificates. ಒಬ್ಬರಿಗೆ ಕೈ ನೋವು ಬರುತ್ತೆ ಸರ್, ಇಬ್ರು ಮಾಡಿದ್ರೆ ಅರ್ಧ ಬಸ್ ವಿಷಯದಾಗ.
Hello. Sir, I can request Dr. Somesha.
Sir, Dr. Somesh, sir, please.
Wait here, sir. Dr. Anita.
Okay, okay.
Dr. Kusuma. Dr. Ramachandra. I think he hasn't come. Yeah. Dr. Nagesh. Dr. Nandini. SJ Polytechnic, Seshadri Road, Vijay Kumar. Vijay Kumar, sir. Mr. Baira Reddy. Bandila answer. Adarsha KS. Shweta J. Ravi BL. Dr. Hanumesh and Vinita M. Okay. Then Government Polytechnic, Immadihalli, Gayatri V. ನೀವು ಕೊಡಿ ಪರವಾಗಿಲ್ಲ. ಗಾಯತ್ರಿ ವಿ. ಮೇಡಮ್ ಸರಿತಾ. ಮೇಡಮ್ ಸರಿತಾ. ಎಸ್ ಮೇಡಮ್. ಕಾತ್ಯಾಯನಿ. ಶಿಲ್ಪಾ ಸದಲ್ಪುರ್. ಶಿಲ್ಪಾ ಸದಲ್ಪುರ್. ಬನ್ನಿ ಮೇಡಮ್, ಪ್ಲೀಸ್ ಕಮ್. ವಿಂದ್ಯಾ. ವಿಂದ್ಯಾ ಎಸ್. ನಂದಿನಿ ಸಿ ಎಸ್. ನಂದಿನಿ ಸಿ ಎಸ್ ತಗೊಂಡಿದ್ದಾರಾ? ಗಿರೀಶ್ ಕುಮಾರ್. ಗಿರೀಶ್ ಕುಮಾರ್. Then Government Polytechnic, Channasandra, Asma. Sumitra.
ಪರಿಮಳ, ಸುಮಿತ್ರಾ ಮೇಡಮ್, ಪರಿಮಳ, ಸುಕನ್ಯಾ ಸಜ್ಜನ್, ಸರ್ ಎಸ್ ಜೆ ಪಾಲಿಟೆಕ್ನಿಕ್, ರವಿಶಂಕರ್, ಸಾರಿ ಶ್ವೇತಾ, ಶ್ವೇತಾ ಫ್ರಮ್ ಗೌರ್ಮೆಂಟ್ ಪಾಲಿಟೆಕ್ನಿಕ್ ಚನ್ನಸಂದ್ರ, ಮಮತಾ, ಎಸ್ ಜೆ ಪಾಲಿಟೆಕ್ನಿಕ್, ತೇಜಸ್ವಿನಿ, ಪ್ರಸನ್ನ ಹೆಚ್ ಆರ್, ಬಂದಿಲ್ಲ ಅನ್ಸುತ್ತೆ, ಶಿವಪ್ರಸಾದ್, ಸವಿತಾ ಕಮಲಾಪುರ್ಕರ್, ಶಶಿರೇಖಾ, ಶಶಿರೇಖಾ ಮೇಡಮ್ ಬನ್ನಿ ಮೇಡಮ್, ಹಿತ್ನಾ, ಶೈಲಾ ಮೇಡಮ್, ಬಿ ಎಸ್, ಶೈಲಾ ಬಿ ಎಸ್, ಸತೀಶ್ ಎ ಎಂ, ಸತೀಶ್ ಎ ಎಂ, ಪೂಜಿತಾ ಕೆ ಬಿ, ಪ್ರಸನ್ನ ಕುಮಾರ್ ಬಿ ಆರ್, ಮಿಸ್ಟರ್ ಪ್ರಸನ್ನ ಕುಮಾರ್ ಬಿ ಆರ್, ಶಾಂತಕುಮಾರಿ ಮೇಡಮ್, ಅನಿತಾ ಮೇಡಮ್ ಅನಿತಾ ಹೆಚ್ ಟಿ, ಅನಿತಾ ಹೆಚ್ ಟಿ, ಜ್ಯೋತಿ ಶಿವರಾಜ್, ಮೇಡಮ್, ಭಾಸ್ಕರ್, ಮಿಸ್ಟರ್ ಭಾಸ್ಕರ್, ಶ್ವೇತಾ ರಾಣಿ ಮೇಡಮ್, ಶ್ವೇತಾ ರಾಣಿ, ಯೋಗೀಶ್ ಬಾಬು ಸರ್, ಯೋಗೀಶ್ ಬಾಬು, ಶಾಂತಾ ಮೇಡಮ್, ಭವಾನಿ, ಮೇಡಮ್ ಬಂದಿದ್ದಾರ? ಎಸ್. ಅಶೋಕ್ ಹುಲ್ಲೂರು ಅವ್ರ ಬದಲು ಲೀಲಾವತಿ ಅನ್ನೋರು ಬಂದಿದ್ದಾರಲ್ಲ? ಹಾಂ, ಲೀಲಾವತಿ ಮೇಡಮ್ ಬನ್ನಿ ಮೇಡಮ್. ಇದು ತೊಗೊಂಡಿರಿ, ನಿಮಗೆ ಬೇರೆ ಸರ್ಟಿಫಿಕೇಟ್ ಕೊಡ್ತಾರೆ. ಸಬ್ಜೆಕ್ಟ್ ತಗೊಂಬಿಡಿ ಬಾಪ. ಇದು ಮಟ್ಟಿಗೆ ನಾನು ಅವನು ಸೇರಿ ಕೊಡ್ತೀವಿ. ಕೊಡ್ತೀವಿ ಮೇಡಮ್.
ಕೊಡಿ ಅಲ್ಲ ಸರ್ಟಿಫಿಕೇಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ರಘುರಾಮ್ ಕೆ ಎಸ್ ಆಯ್ತು.
ಯಾಕಂದ್ರೆ ಇವ್ ನನಗೆ ಕೊಡ್ತಾ ಇದ್ದಾನೋ ಅಥವಾ ನಾನು ಅವನಿಗೆ ಕೊಡ್ತಾ ಇದ್ದಾನೋ ಗೊತ್ತಾಗಲ್ಲ ಈಗ. ಅವನು ಇಟ್ಕೊಂಡ್ಬಿಟ್ರೆ
ಹಾಂ, ರವೀಂದ್ರನಾಥ್. सर मेरी पकड़ो चाहिए, you come this side. Nandini VL, Dr. Nandini VL. Usha Rani. Satish BK.
ಸ್ವಲ್ಪ ಈ ಕಡೆ ಬನ್ನಿ, ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಬನ್ನಿ.
Satish BK.
Satish ji.
Shri Varshini.
All the best, sir.
Uma Shankar. Jairam.
Thank you.
So we have left out with some more certificates here.
Once again, call once more.
Bhaskar, Girish Kumar, Prasanna Kumar BR, Satish AM, Baira Reddy, Prasanna HR, as well as Parimala. Huh. Okay, madam. Okay. Bhaskar ಅವರು ಬನ್ನಿ ಅಲ್ಲಿ ಬನ್ನಿ ಅಲ್ಲಿ ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಗಿರೀಶ್ ಕುಮಾರ್ తీసుకోండి.
ಗಿರೀಶ್ ಜಿ, ಗಿರೀಶ್ ಕುಮಾರ್.
ಪ್ರಸನ್ನ ಕುಮಾರ್. Okay. Three are we need to thank them.
Yeah. On behalf of Liquid Instruments and my Department of Technical Education and Spruha Built-in Solutions, Bangalore, I thank everybody, all the participants for having participated and made use of this technological session, and then endeavor into applying this in your future academics to elevate the standards of the students. Thank you so much.
On behalf of Spruha Solutions, we would like to thank Mr. Professor Vivekananda as well as Professor Ramchandra Shastri for being with us and making this event very successful. With thanks once again. Sridhar, one ನಿಮಿಷ. Sridhar, ಬನ್ನಿ. ಒಂದು ನಿಮಿಷ, ನೀವು ಒಂದು ನಿಮಿಷ ನಿಂತ್ಕೊಳ್ಳಿ. ಒಂದು ನಿಮಿಷ ಆ ಗಿಡ ತಗೋ.
ನೋಡಿ ಆಯ್ತು, ತುಳಸಿ ನಾಳೆ ತುಳಸಿ ಮದುವೆ. ತುಳಸಿ ಮದುವೆ ತುಳಸಿ ಹಬ್ಬ ಮದುವೆ. ಹೌದು,
ಕೊಂಚ ಮಾಪಕ ಹಾಕೋಣ.
ಬಂದೆ ಸರ್. ಓಕೆನಾ?
ಇದು ಕಾಣಬೇಕು ಅಂತ ಅವರು.
ಓ ಗುಡ್. ಓ ಇದು ಥ್ಯಾಂಕ್ ಯು.
Professor Vivekananda once again.
Yes, Jai.
And we heartfelt we are facilitating Mr. Professor Ramchandra Shastri also for making this event a big successful one.
His father is from Sir C.V. Raman Institute. His father was colleague of Sir C.V. Raman.
Thank you. So thank you all, and we have a lunch session. Please carry on. We would like to thank Ravi, who has been very helpful from Planetarium, Mr. Srinivas, and we will be very glad, and we should thank Rajeshwari Madam as well as Director Guru Prasad. Thank you very much for helping us in happening this event to be a very successful one. Thank you.